space, seeking knowledge, wisdom, and connection. We pray for clarity of mind, open hearts, and engaged spirits. May our discussions be fruitful, our interactions be respectful, and our learning be transformative. Guide us with your presence, and may your wisdom be our foundation. In your name we pray.
Amen. Thank you so much for the word of prayer, St. Gabriel High School. Allow me to share again my screen for our friends that have just joined in. Today we are running our second day of the seminar, and this is how our program will run. We would like to welcome, first of all the schools that have joined in and all the students that are joining in from the different parts of the country, but also all the teachers that have been able to join this call. You are most welcome, and thank you so much for joining. I would also like to thank the school administrators who may be on this call for all the support that you have offered to the students, to the teachers, to be able to join this call, but most importantly, to be able to be online to share the knowledge. Thank you so much, dear head teachers and all the school administrators that are making this very possible. In our discussion today, we are going to be sharing knowledge of mathematics. Mathematics is a subject that requires doing. So we are going to be doing, we are going to be calculating numbers, and we are going to be sharing knowledge such that all of us at the end of the day, we can benefit, such that at the end of the day, all of us can be able to pass our exams that we are yet to do in a few months from now. And what are the questions that we are going to be discussing? Yesterday, we were able to do some numbers, but I do understand that not all numbers were done, and therefore we shall go through all the numbers, most importantly, those numbers that were not done, such that we can be able to catch up, but also to be able to complete all the questions that we had in the seminar. Now, the questions that we are going to deal with, in case you have not yet received them, these are the questions that I'm displaying on my screen. So the questions we are dealing with are here. So hope my screen is clear, but we are going to move from one number of from one item to the other, but most importantly, we want to ensure that at least we touch something on each element of construct, such that we can be able to cover comprehensively whatever we have prepared or whatever is contained within the seminar. So these are the numbers that we are going to be discussing. And during the sessions, when someone is discussing, always feel free to chip in, always feel free to ask any questions that you may have. Always feel free to ask, such that you can be helped to understand what we are covering. So these are the questions that we are going to be dealing with, and I'm going to invite those schools that would like to be the first to present to let us know, such that we can now give you the rights to be able to start. Yes, any school that wants to be the first to discuss, kindly raise up your hand, and then you lead us in the first discussion. Yes, Moloto High or Odraf?
Consider Stephen.
Okay, I'm going to first mute the participant, such that we can start off. Okay. Okay. Yes. Any school that wants to be the first to discuss, kindly let us know. You can use the chat in case you want to be the first to discuss the questions. Okay. Okay. I'm going to share my screen and we shall go through the first item. Yes, teacher Noel, you let me know when you are ready. Okay. Now, this is the first item we are going to share on. Yesterday, there was one approach that was used, and today I wanted to start with the second approach that we can use. So we are going to start with item number 14. When you look at item number 14, is telling us that Stephen is starting a juice business and plans to serve his juice in special designed conic cups. Now, when you look at this item lies in what you call geometry and measures. And this item is testing for your skills as a child or as a student in areas such as similarity. That is one of the areas that is being tested here. Is testing whether you know the formulas for area, volumes, and length. This is also testing whether you know about the different dimensions, the 3Ds. So that is where this topic, that's where this particular item is. Now, after identifying, you ask yourself, which approach is much easier for me to be able to use? Now, when you look at this item, since they are asking, when you look at the item, they're asking us, estimate the amount of wrapping paper in square meters required to cover the curved surface of one conic cup. What does it mean? It means they're asking us, some of you have been taking juice. So they're asking us, how much paper is required to cover this space here, the curved surface? Now, whenever you have a cone, this is my cone, and this is my complete cone. That is my complete cone. Now, this area here is what we call the curved surface area. Sometimes you can call it the lateral surface area. Now, this line here is what you call the lateral length. So sometimes you can call it the lateral length. Now, when you look at the kind of figure we have, this kind of figure we have is called a frustrum, which is obtained by truncating, by just cutting the cone. So once a cone is cut, it means that when you cut it, you are going to remain with a figure of that nature, which is equivalent to this bucket that we have, which is equivalent to this cup that we do have. Now, what does it mean? In case we want to find the area of that particular, of this particular one here, it means that we need to find the area for this curved surface. And how do we get the area of the curved surface of the cone? So the area of a full curved surface of a cone is given by pi r L. But when you look at the figure we have, the figure we have has been cut, meaning that you cannot be able to find it without you completing it. Now, always the first thing you do, in case you meet these figures of frustrum, you need to first know which figure was being cut in order for us to be able to obtain that particular frustrum. So now for our case here, what we have, what was cut was a cone. So that means that in order for us to be able to continue, we are going to first form our cone by completing our figure. So we shall complete the figure. We shall complete the figure like this. Now, in your formula, pi stands is 22 out of 7. R is what you call the radius of your cone, and L is what you call the lateral length. The lateral length is this length here for the cone. That's what you call the lateral length. Oh, someone saying is unable to see my screen. Kindly let me know in the chat whether everyone can see the screen. Someone, Van Tyler Christian High School, is saying they're unable to see my screen. Can someone let me know through the chat whether the screen is visible? Are other schools able to see the screen? You may type in the chat. Okay, it is visible. It is visible. Okay. Now, the first thing we are going to do, we are going to complete, but I was telling you that pi is the 22 out of 7, r stands for the radius, and L stands for what we call the lateral length. So what are you going to do? It means that in order for us to find a curved area, I'm going to come, this is our cone that we do have. So this is my cone that I'm going to complete. This is the cone, and the figure that was given was cut from here. Now, when you read the question told us that this particular cone that we are dealing with, it had a diameter of 8. So this is the diameter, which was 8 centimeters. Then they told us that down here, this was the height, but from here up to here, they told us it was 4 centimeters. So down here, you have another circular figure of that nature. So for it, it had a radius of 4. Now, what does it mean? It means that when you complete your cone, you have two things you have formed. You have formed this downer part from here up to here, that is a cone, and you have this wall, the bigger one, which is also a cone. So we are going to have two things. We have what we are going to call the bigger cone, and also we are going to have what we call the small cone. The small cone is the one that was cut. Now, when I come to the big cone, this is my cone, and when you look at this big cone, it was 8 centimeters. So I'm going to complete it. This is the completed one. But when you go back to our question, when you go back, you can notice that here they told us it was 10 centimeters. So when I come here, this is 10. That means that when you look at our figure here, from here up to here is equal to 10. But we don't know what was the height of the other cone that was cut. So I'm going to say, let h be the height, of the small cone. So that means that from here up to here, we shall have h. So meaning that here, we shall have h. So what does it mean? It means that the total height now for the cone we have is going to be 10 plus h. Now, when I go to the small cone, this is the small cone that I do have. So the small cone, we have said that its height is going to be h. But they gave us its radius, and its radius was given as 2 centimeters. Meaning that if you want its diameter is always twice, meaning that its diameter will be 4 centimeters. Now, when you look at the two figures, these two figures are similar. And meaning that in order for us to find this unknown h, we are going to go on and find and use the similarities to be able to find it. Now, when we are applying our similarities, here we shall say applying similarities. Now, when we are applying similarities, it is up to you. So we can say big divided by small equals to big divided by small. In other words, you compare the size of one bigger part compared to the other one. So I'm going to be comparing the bigger cone with the smaller cone. But when I'm comparing, I will be comparing the same things. In case I'm comparing diameters, I compare diameters. In case I'm comparing radius, I compare radius. In case I'm comparing height, I'll compare the height. Now, when you look at the bigger cone, its diameter is 8. I'm going to compare it with the diameter of the small cone, which is 4, equals to the height of the bigger cone, which is 10 plus h, divided by the height of the small cone, which is h. Now, always please take note, in case on your left you started with big out of small, please do not interchange when you go to the right. Also have big out of the small. So compare big out of small, big out of small. In case you want, then compare small out of big, small out of big. At the end of the day, you'll be able to obtain the same answers. So it is up to you. it is up to you to find what you do want to get. So I repeat, for the small radius, for the small cone, its radius was 2, so the diameter is 4. When we go to the bigger cone, its diameter was given as 8. So I think this was, okay, maybe someone saw this, but here, this was the 4. Now, I'm going to go on and I do the cross multiplication. So when I cross multiply, I'll have 8 times h, which is 8h, is equal to 4 into 10 plus h, which will give us 8h is equal to, you open your brackets. Remember, when you are opening, this one affects the inside, so it becomes 4 times 10, plus this 4 will affect the h, and it becomes 4 times h. So this will give us 8h equals to 40 plus the 4h. Now, from this point here, you're going to be able to collect like terms. So I'll have 8h minus the 4h is equal to 40 plus 4h minus 4h. So 8 minus 4 will give us the 4h equals to 40. So in order for us to find h, I will divide both sides by h. So I'll have 4h is equal to 40. So I divide by 4, I divide by 4. So I'll end up with my h as 10 centimeters. That means that the part that was cut off was 10 centimeters in height. So in case now I want to find the height of the bigger cone, it means that I'm going to use this height I've obtained and the other height of the other cone. So hope this is very, very fine to everyone. Now, when I go back to the cone that I'm dealing with, and now I'll have a cone of this nature. This is our cone like this. But remember, we have said in order for us to get the area, it means we must get the area of the lateral surface. So this is what we call the perpendicular. And here we have this as the radius. So in order for us to be able to find this side, what we call the lateral length, here we have the 90. So you notice that the figure we are forming is the right angled triangle, of which here, in case I'm dealing with a small one, this will be 2, and here we shall have 10. So that means you can be able to find the lateral length for the small cone. In case it is now for the bigger one, I'll have this, I'll have this, and I'll have this. So for the bigger one, here you have your radius is going to be 4 centimeters. Then down here, it is your height. Remember, this was 10, and also here for our h, we have obtained 10. So the total height is going to be 20. So here we shall have our 20, and here we shall have our 4, and then we are going to go on and find what we call our lateral length. So those are the two figures that we are going to be dealing with. Now, when I go, now what am I interested in? I'm interested in finding what is the lateral length. What is the lateral length for the bigger cone and what is the lateral length for the smaller cone, such that I can be able to obtain their areas. Okay, now I'm going to come here and I have, this is my figure that we have formed, and we have said that here for the bigger cone, here I'll have my 4 and my height will be 20. So allow me, I can say let's LB be the lateral length, of the bigger cone. So now remember, this is 90. So you notice that you have a right angled triangle of that nature. So this is 4 and this is 20. So in order for us to find this LB, we shall apply our Pythagoras theorem. And you know from your Pythagoras theorem that always your a squared plus b squared will give you the c squared. Now for such a case, it means that we shall have 4 squared plus the 20 squared is equal to LB squared. But please avoid going straight. Place and ask yourself, what is 4 squared? That 4 squared will give me a 16. Plus, what is 20 squared? 20 squared will give us a 400 equals to L squared B. So 16 plus 400 will yield for us 416 equals to L squared B. And in order for us to find the lateral length, we shall get the square root on both sides. So I'll say 416, I get a square root. Also, I come this side, I'll get a square root. So I'll end up getting the square root of 416 as LB will equal to 20.3961 centimeters. And always I advise that if you have not yet reached the final answer, always let's have as many decimal points or decimal places as we can. Let's not limit to only one, but make sure at least you have 3 or 4 decimal numbers after the decimal point. Now this is for the large cone. Then for the other small cone, you have noticed that for it, here we have the 10 centimeters and we have the radius of 2 centimeters. So allow me to say that let LS be the lateral length for the smaller cone. So this is LS. So still you go back and apply your Pythagoras theorem. So you shall have 2 squared plus the 10 squared equaling to LS squared, which will give us 4 plus 100 equals to L squared S. So this becomes 104 equals to L squared S. Then what do? We are going to take the square root on both sides. Take a square root, take a square root. So the root of 104 will give us, we shall have LS equaling to 10.198 centimeters. Now, after obtaining the lateral length, it means that now you can be able to obtain what your area for the bigger cone and what your area for the small cone was equaling to. So what am I going to do? I'm going to come and say that now my area, the curved surface area of a cone, so is given by pi r L. That's how we find the area of the curved surface of a cone, pi r L. Now I'll come here and let's say area of the curved surface for the bigger cone. For the bigger cone. So always I encourage you to have subtitles for whatever thing you are making the calculation for. So we shall have area equals to pi RL. Now, when it comes to pi, always consider 22 out of 7 unless the question has stated or has told you to use another pi, maybe 3.14. So this will be 22 out of 7 times the radius of the bigger cone, which was 4, times the lateral length, which was 20.3961. So what you do, you place now your calculators, place your calc. So when you place your calc, you will notice that you are going to obtain an answer 256.4081 centimeters squared. This is for the bigger cone. Then I'm going to come this side where I'm calculating for the small cone, and I say area of the curved surface of the small cone. So still the formula is the same. Area is pi RL. So this will give us 22 out of 7 times the radius of the small cone, which is 2, times the lateral length, which is 10.198. So I'll go on and say 22 times 2 times 10.198 divide by 7, and I'll end up with an answer as 64.1017 centimeters squared. Now, why do okay, St. Elizabeth, uh, okay, I think it is okay. Oh, the person who is not hearing, maybe your volume is not on. Maybe your microphone is not on. That's why you are unable to hear us. That's why maybe you're unable to hear us. Okay. Now, after obtaining the area of the curved surface for the small cone and the one for the bigger cone, remember when we try to visualize what we have is like we have, this is our cone that we have. This is our cone. So when you look at our cone, it was cut in this format. So you have obtained the area for the whole of this part here for the bigger cone. Then you have also obtained the area for this part here, down here that I'm shading here. So in order for us to be able to obtain the area for this part that is remaining here, this part here, it means that we are going to get the area for the bigger cone minus the area for this small cone. So in order for us to get the area of the cone that they made, it means we get the area of the bigger minus the area for the small. So I'll come and say that area, okay, allow me to use this, area of the conic cap will equal to the area of the big cone minus the area of the small cone. So here we have our big cone as 256.4081 minus 64.107. So what you do, you place now your calculator and then you subtract that. So when you subtract, you'll end up with an answer as 192.306. That is the answer. I am obtaining 6.4, and these are centimeters squared. Now, this is the area of your conic cap, but you have not yet obtained it in the units that they told you, because when you go back to the question wanted you to give us the amount of paper required, but in square meters. Meaning that in order for us to present it in the square meters, we have to go back and change our centimeters squared to meters cubed. So that is what we have to do. So we are going to go back and get that answer we have been able to obtain and then convert it to, we are going to convert it to the required units of meters cubed. But always as a student, you need to remember this one is going to be very key for you. It's going to be very key for you. So you remember we said that K, you remember this. And what do you want to convert? You want to convert from centimeters going to meters. So in other words, you have 0, 0, and 1. What does it mean? It means that in 1 meter, you have 100 centimeters. So whenever you are moving, so a centimeter is small compared to a meter. So whenever you are moving this from, whenever you are going this side on your, this is your left, and you are moving from your right. Whenever you are moving from a smaller unit going to a bigger unit, always we shall be dividing. But do not forget that our area we have obtained is in centimeters squared. So mean that also here we are going to square in order for us to work in the same units. So that means we shall say squared and then squared. So we shall have 1 meter squared equals to 100 centimeters times 100 centimeters, which will give us 10000 centimeters squared. So that means in 1 meter squared, you have 10,000 centimeters squared. What do you want? So in case you want one, so what do you want to convert? We want to convert the area that we have obtained as 192.3064 centimeters squared to meters squared. So 1 meter squared is equal to 1,000 centimeters squared. Then you ask, how many meters, that's what I'm calling X, are equivalent to 192.3064 centimeters squared. Now, what does it mean? It means it is just a matter of you dividing. So when you cross multiply, the way you are used, you can just cross multiply like that. And the moment you cross multiply, you'll end up with your 10,000 of x equaling to 192.3064. Then you divide by 10,000, divide by 10,000. So the moment you divide, you'll end up with obtaining your answer for the wrapping paper as 0.01923064, which you can write to maybe for the small point numbers as 0.01923 meters squared. Then now, for whatever question, dear students, that we meet, do not forget to make a conclusion, because you must respond back to the item and to the task. They told you that estimate the amount of wrapping paper in square meters required to cover the curved surface of one conic cup. So I do expect you that you are going to conclude and say, therefore, Stephen needs 0.0192 something of wrapping paper so as to cover the curved surface of one conic cup. So that is what you call now you are responding back to the item. Let me hope that is very clear to everyone. So that is how I expect you to conclude for the first part or for part A. Now, when we go to part B asks you that determine how many cups are needed to fill the 20-liter juice order and calculate the total cost of wrapping all the cups needed. Now, this question, when they ask you, this person has obtained an order on which this person has to supply 20 liters of juice. Now, you may ask yourself, how many cups does he need? In order for you to know how many cups you will need for the 20-liter juice, it means that one, you need to know the volume, the capacity that conic flask holds, that conic cup holds. What does it hold? That is the first important thing you need to know. That if I have one cup, how much juice does it take? Now, how much juice refers to the capacity, which relates to what we call the volume. So this question was indirectly asking you to first obtain the volume of one cup. After obtaining the volume of one cup, then you go on and obtain what the number of cups that can fill the 20-liter juice. So I'm going to go back and now we look at that part. Okay, I'm going to go back and we look at now that part. Now, when we come to the volume of a cone is obtained from a cylinder. When you have a cylinder, this is my cylinder. You can look at it. When you look at a cylinder, this is a cylinder and this is a cylinder. That is the same. So in order for you to get a cone is obtained from a cylinder. When you look at this figure or what I have drawn, you can note that from it, you can obtain 3 cones. So what does it mean? It means that the cylinder here, we know that to get volume, always volume is obtained from what we call the base area times what we call the height for that particular figure. So this figure we have is a cylinder, and the base area, when you look at the base here, what we are calling the base, this is a circle, and this circle, its area is obtained by pi r squared. So the base area is pi r squared. This is volume of what? Of the cylinder. Then times the height. This is what we call the height, which is h. Now, in case I want to obtain the volume of a cone is obtained from a cylinder, and one cone covers a third of the total volume a cylinder can occupy. So this is 1, this is 2, and this is 3. So one cone is equivalent to 1 out of the 3 of the total volume of the cylinder. So in order for you to get the volume of the cone will be a third of the pi r squared height. So whenever you are told to get, you are calculating things of the cone, always relate it to the cylinder. The moment you know how to obtain the volume of a cylinder, it means that for a cone, one cone occupies just 1/3. In case you have, this is your cylinder, and this is, let me say this is our cylinder. When you get your ice cream thing and you pour it in the cylinder, the first part of your cone will fill up to this part. The second part will fill up to that part, and the third one. In other words, in a full cylinder, you need 3 cones in order for you to be able to make it to full. So that's what we call the volume. Now, in order for us to find the volume or the capacity for the particular one we have, it means that I'm going to first obtain what is the volume of the bigger cone that we had. Then after obtaining the volume of the bigger cone, remember you had a bigger cone and a small cone. So you're going to first obtain the volume of the bigger cone, which had a height of 20 and it had a diameter of 8. Then this one had a radius of 2 centimeters. So I expect that we are going to first obtain the volume of the bigger cone and the volume of the small cone, and then we subtract, such that we can be able to get how much juice this one can hold. So we have said volume for the big cone, allow me to call it volume VB, is equal to a third pi r squared height. So for the big cone, this will be a third times the 22 out of 7 times the radius, now which will be 4 squared, then times the height, which is 20. So what you do, you go on now and have your calculator, and then you place in to see the answer you get. But it is very important that now, dear students, start practicing, because some of you sometimes do fail because you don't know how to use the calculator. Yes, so make sure you utilize your calculator very well. And these are centimeters cubed. From there, we go to the volume for the small cone. So still the volume for the small cone will be a third pi r squared height. Remember, for the small cone, its radius here is 2. And when you look at the height here that we had, its height was 10. So it means we shall have a third times the 22 out of 7, then times the radius, which is 2 squared, times the height, which is 10. Then you go on and place your calculator. So when you place your calculator, we shall have our answer here as 41.90476, and these are centimeters cubed. Now, what do you do? Since you are interested in this part that remains, remember you have, this is our cone that we had. Then we have obtained for the wall shape. For the wall shape, we have obtained everything here. That is the first thing we did. This is the volume here. Now, we have also obtained for this part here down here, this part that was cut from this point. Now, in order for us to get what remains here, it means we are going to get the big minus the small. So we shall say that the volume of the conic cap will equal to the volume for the big minus the volume for the small, which will be 335.238 minus 41.90476. So what you do, you put on your calculator still, and then you subtract 41.90476. So we shall end up with our volume as 293.33324, and these are centimeters cubed. That means that your cup, your cone, this is the amount it can hold. And dear students, if you have not yet reached your final answer, avoid premature approximation. Avoid rounding off before you reach your final answer. Take an example. Don't write this as 42. because you have not yet reached the final answer. Don't write this as 335 because you have not yet reached the final answer. So that's what we call premature approximations. Always make sure that if you are to round off to the nearest thing, you do it at the end. Now, these are centimeters cubed, but the order the person received was in liters. Now, meaning that you must now be able to convert the volume of the conic cup to the liters such that you know how the volume of in liters that cup can hold. Now, there are some units of measurements that you need to know. Sometimes they will not give them to you, but as a student, you need to know them, that in case I have 1 liter, how many centimeters cubed are there? So some of those things, at least make sure that you know them. Yes, so one thing now we need to know is that when it comes to 1 liter, 1 liter has 1,000 centimeters cubed. When you want to refer to a liter, are those who have cups that you use to take maybe porridge or tea, or a cup of milk. That cup of milk is a half a liter. Half liter means 1 cup, but the cup I'm referring to are what you call like your gammas at home. I don't know, those gammas we use at home, those tampecos we use at home, those kind of cups, those are what we call, that is half a liter. So when you have 2 cups of that nature, there are these cups of ours we use at home to take tea. This cup has 500 centimeters cubed. So it is just a half a liter. So 2 liter, 1 liter, it means you must have 2 cups of that nature. Another example we can use the Renzori bottle. That bottle of Renzori, or that small bottle you buy of 1,000, it has 500 centimeters cubed. In other words, it is a half a liter. So it has just 1 cup. So that means 1 liter must be 2 cups. So 1 liter is 1,000 centimeters cubed. And what do we want now to convert? We want to convert what our volume that we have. Our volume we have is 293.33324 centimeters cubed, and we want to convert it to liters. Now, when you look at a liter and centimeters cubed, you notice that a liter is bigger compared to a centimeters cubed. And I told you already that whenever you are moving from a smaller unit going to a unit that is bigger, always we shall be dividing. So allow me here now to say our volume of the conic cup in liters will equal to 293.33324 divided by 1,000. So when you divide by 1,000, you'll end up with 0.293333, and these are going to be your liters. Now, after obtaining the liters, remember the order that you have obtained is for 20 liters. So you ask yourself, now, how many cups will I need? Now I will say number of cups needed to fulfill the order of 20 liters. So that means you're going to divide. So I'll have the 20 liters divide by what 1 cup can contain, which is this. So you go to your calculator, you divide 20, divide by 0.293333. So your answer you are going to obtain here is 68.18189. And these are the cups. That means that in your order, what you have placed, these are the cups. But now when you reach this point, you start reasoning out that now, how many cups would I need in order for me to fulfill the what? The order. How many cups do we need? Yes. So in order for you to know now the number of cups, because you may not be able to take on the 0.18189. So here you make an approximation that approximately 69 cups will be needed. Why 69? Because if you consider 68 cups, it means that the order of 20 liters, it will not be fulfilled. In other words, you may find yourself that the cups you have taken can only fulfill around 19 point something liters. Yet, you had to fulfill the order of 20 liters. So here the approximation can be, you can conclude and say, therefore, Stephen will need approximately 69 cups to fulfill the order of 20 liter juice, the order of the 20 liters. So now here is where you need now to reason. Some questions may require you to round down. Some questions may require you to round up. So you need to reason. Does it make sense? Take an example. There are questions you're going to meet in the same topic, whereby in case it is iron sheets, and they have told that this person has gone on maybe to buy maybe iron sheets, has gone to a wholesale and the rest of that. Now you need to ask yourself, if I take it, let me say we are painting a house, and these are the number of tins you need. It means that when you say 68 tins, it means that the house will not be painted fully because the color will not be enough. So you reason out, am I going to round up? Am I going to round down? Here, it does not matter whether there is 5 or no, because if there is 5, then that is okay. You know you round it upwards. But sometimes if there is 1, it is now the reasoning that we use in order for us to make a conclusion. So here, I expect you now to make your conclusion. Therefore, Stephen will need this and this number of cups to fulfill the 20-liter jerrycan order. So that is what you had to do when it came to the number of Kwanike cups. Then when I go back, they told you that and calculate the total cost of wrapping all the cups needed. Now, when you go back to the question told you that he has found a supplier who charges 30,000 per square meter for the wrapping material. Now, you ask yourself, how many meters do you need for you to be able to wrap? So when you look at the meters we do have, we had 0.019 something. Those were the meters we had. So in order for you to be able to get the amount, what do you need? So you go back to the area you need. So when you look at the area we needed, this was the area. This was the area for one wrapping paper. So in case you are going to use 69 cups, how much paper will you need? It means that you'll get your 69, then you multiply times the meters that are needed or times the meters that you are going to use. So that is what you are going to do. Then after doing that, you get the total amount of money that you need in order for you to make the calculations. So that's what you have to do for that part. Then the last part required you. Why is it important for Stephen to carry out these calculations before starting the production? Now, such a question is testing your business sense. That if you are to carry on a business, what are some of the things you need to go on and think about? So here we may have varying answers, and those answers will depend on a child's reasoning. So we may not have a specific answer that this is the answer, but it will depend on a specific reason that a child gives out. So someone may say it is because maybe to be able to predict the expenditure and plan accordingly so as to maximize the profits. Yeah, because one of the reasons why we plan, it is because why we go into calculations before we start on any business venture. We want to know, shall we be able to maximize profits or shall we making losses? Then also you need to know, how much of a given quantity will I need such that when I go to buy, I don't waste. So you want to minimize on the wastage. Instead of buying a lot of things that you are not going to use, you first go into calculation to know that now I want this and this. And now here, even for the reasoning, it would be better. Now take an example. In case I'm talking about the wrapping paper. Here you know that for wrapping paper, why you make the calculation is that you want to minimize on wastage such that when you go to the shop to buy, you do not buy more than what you need, because when you go to buy some of these things, they sell in meters, so you will be very sure of the meters you will need for that particular project. In case you're going to buy the cups from somewhere, then you'll be able to know how many cups you will be needing. So that is the kind. So it depends on how you reason out for that particular thing. Now, questions. Yes, questions of geometry and measures. There are certain key things we need always to pay attention to. And one of the things we need to pay attention to, one of them are the units. Be very careful when it comes to the units. Dear students, do make sure you know how to convert units from one unit to another, from one unit to another. That one is very important because they are testing you. Does this child know how to convert from one unit to another? In case you don't know, then that means that that's where you are going to start messing up your scoring marks. Then number two, they are also going to check out. Do you know how to make sketches? Yes, when it comes to geometry, sketches are very important. So do not forget, whenever you find this is geometry, one of the things that is very important, one, we shall look at the correct sketch. Make sure that when you are dealing with an item on geometry, for items that involve sketches, make your simple sketch. Here you are in this particular one. This is where you're going to find things of bearings. This is where you're going to find those questions of construction. So meaning where you're going to inscribe, circumscribe, and the rest of that. So make sure that when you are dealing with this particular item, you are well conversant with how to draw accurate diagrams. And that it is at this point that I want you, before you go in for your mock papers, for your UNEB, make sure that the mathematical set you have has the instruments whose measurements are accurate. Not all sets that you buy from the shops, their instruments are accurate. We have found out that there are sets whose measurements are not so accurate. So make sure that you go in for a set whose measurements are accurate. Most of sets that are below 3,000 uh, that are below or equal to 3,000 and less, some of their measuring instruments are not so accurate. So make sure you look out for a set whose measurements are accurate. Otherwise, when you measure, you may find yourself that you are measuring 9 centimeters, yet the instrument that is there for it is giving you 8.4, and you keep asking, I'm doing all what it takes, but things are not coming out. So make sure you get something. Even the compass that is inside, sometimes they are very loose, so they keep on disturbing you. Make sure you also follow the instructions. All these items in geometry, they have certain instructions they want you to follow. So make sure that you follow the instructions that have been given to you such that you can be able to maximize. So some of the scoring areas that you need, they are going to look out for. Are you able to use a scale? Are you able to have a consistent scale? Remember in geometry, whenever your scale is wrong, many of the things you are going to be doing also will be wrong. Remember, when you are making a sketch, in under the geometry, for sketches, it is okay to put the kilometers, to put them the meters and other units. That is, I'm talking on the side of I'm talking about the side where you have a scale. But when it comes to making an accurate diagram, please, some of you go on and put on your diagrams things that really are not good. Take an example. In case this is your sketch, you have made your sketch. Let me say this is your sketch. On your sketch, you have put 2 kilometers, 3 kilometers. This is very okay, and you have put 60. This is very okay for a sketch. But when it comes to the accurate diagram, we expect to see where have you converted the units from. Conversion of units. Put it there. Say scale conversion. Then say we want to see what does your 1 centimeter represent. That maybe 1 centimeter is equivalent to 10 meters. Then show that you are converting, that I will have 50 meters divided by 10. So this one will be equivalent to 5 centimeters. Show how you are converting from the scale. Some of you, I know you are very quick. You are very good at mathematics. For you just go and say, this 50 meters is equivalent to 5 centimeters. Then you draw your sketch, you draw or you convert your units in the head. That one, it means that you are going to miss a mark for a scale and for showing that you have converted your scale. Having a sketch also gives you a score. Make sure that you have a sketch, because this one will be scored. Then after, and please make sure you write titles, that this is a sketch. Now this is my accurate diagram. Accompany it with a subtitle. This is my accurate diagram. Then you go on and then you draw your accurate what? Accurate diagram. So for any diagram you're drawing, give it a simple title, that this is accurate diagram, this is my sketch. Because some of you, you may not name it and someone can easily mistake it, that maybe this was a sketch. So make sure you draw your accurate diagram. But also in the area of geometry, please, sometimes you need to know the names for the different figures. I think those who noticed last year, you noticed they were asking for some figures for one of the numbers that was brought. That was number 6. And children didn't know the name of the figure. So you need to know, is it a right angle triangle? Is it yielding a scalene triangle? Which kind of triangle is it yielding? So you need to know now the different names for the different types of figures. Rectangle, triangle. Remember, triangles, we have different figures. We have those ones whose sides are equal. We have those ones where all the sides are not equal. We have those ones that have 90. So you need to know what are the specific names. And even you need to know the reason that if something is isosceles, it means that two sides are equal because the base angles are equal. In case something is scalene, why? All sides have different what? Length. So you need to know the kind of reasoning. In case it is a right angle, it is because of this and this. So all those things are very important when you are handling an area concerning geometry. I want to repeat, give subtitles for whatever thing you are calculating for. In case you have found a number, maybe inscribing, circumscribing, what and the rest, give it that now I'm finding the area of the triangular garden. Then show you're working very well. That now I'm finding the area of the circular fence. Show you're working. I'm finding the area for the paved part. Show you're working. I'm finding this and this. And when we are writing, always kindly write vertically. Make sure your work flows in a vertical format. Don't write side by side. You have, like I write here. Let me say, let me first clean this space quickly. Let me say, this is your piece of paper and you are making your presentation, that you are finished to draw, and you say area of this, then you write area of this, then you make your calculation, area for this. This is the best way. But don't write and say area of this, then after you say area for this. Area for this, whereby you write here one side, side by side. Even some of you make it worse. You go even and you divide your paper. Don't divide the paper. Ask for as much paper as you need. Then make sure that your work flows very well in a vertical format, such that someone scoring can be able to score you very well. That now you're finding the area, then someone will come and say, here you deserve a score 1. Here you deserve a manipulation. Here you deserve this, something like that. Then the last thing on this part is the response. A response is items that are being said, there is always a problem they want you to solve. Now, whenever there is a problem they want you to solve, you must respond to it in other, like giving an advice or giving what you think. So that means that you must always respond back. Always, that is the last task. So you must be able to respond back that the amount needed for this and this is this. So that one will be awarded. So they will say AP4, AP4 is equal to 1 because this is the element of construct number 4. So please make sure you respond back and in words. Don't just say, this is okay. Now, the same thing for the other item we have been handling. We expect you to conclude and make a good conclusion basing on what you need. But also, please do not forget that units. So when we are dealing with money, and in case the question for these items is in Ugandan shillings, please write UGX and put the amount that is there. Maybe this is the amount, something like that. Don't put shillings and you say shillings and in the question didn't use it. In case the question is using shilling, use shilling. In case they use UGX, stick to UGX. But remember that currently we are advocating for UGX. We are advocating for UCH because shillings is not is a general term for a currency. So it can be any currency for any country. So in case they be very attentive to the kind of units they have used. And units here are very crucial for this geometry and measures. Do not forget to write your units that these are meters, these are centimeters, these are kilometers. And sometimes some of you forget to convert back after measuring your thing from your actual diagram, you forget to convert back to the scale that you used. So please do not forget to convert back and also show how you are converting. Let me say you have measured your radius, you have measured something, the distance, the direct route, and maybe you have obtained 10.04, maybe 10.4 centimeters. Then you go back and convert now the 10.4 times the scale used and then get that answer, report it to kilometers. So that is briefly about this. But I repeat, do not forget those subtitles. Do not forget the units. Clearly show your working. Don't do shortcuts because those things you are eliminating, thinking that are not important. You may find that those are the points that they are going to be able to score. Yes. And for responses that require you to say yes or no, please make sure you respond clearly because sometimes they'll ask you, will Stephen be able to take on the order? Then I know your response will be yes or no, but don't be a plain person and say yes, so what? So say yes because this and this. Yes, because the amount of money that Stephen will generate will be enough to do this and this. No, because of this and this. So don't just give a yes or no response. Back it with a reason and back it up with figures to support your argument. So that is briefly about this particular item or briefly about geometry. Now, in case you have any questions, feel free. Okay, now the number of decimal places. Here I would encourage you to carry on 4 decimal places up to when you reach for some numbers, 4 decimal places are important. Yes, if you have not reached the final answer, don't do premature approximation. Take an example, these numbers that involve like the number we have done. Don't quickly round off to 20.45, yet you are still going to use that value. If you have not reached the conclusion part, please carry on at least 4 decimal places such that your level of accuracy is within the boundary. Otherwise, when you terminate your decimal places at an early stage, it means that you are going to have a big error. At the end of the day, the percentage error is going to be very big compared to someone who carried very many decimal places. Terminate the decimal places, truncate them at the end, but not at the start or in the middle, but let's do it at the end of the what? Of the conclusion. Then here also they can set an item whereby it requires you to round off to the nearest tenth. Take an example. Sometimes you may meet a question whereby you have calculated money and you find that the money you have is like this. And you ask yourself, but the question may ask you that round it off to the nearest thousandth, something like that. So you need to know now how to round how to round those figures. So they may say round it off to the nearest this or write it to two significant figures. Take an example, they will say write it to only one significant figure or write it to two significant figure. So in case it is this, we expect you now as child to write that. So please, that one, hope it is very clear. Okay. Okay, I think allow me to end here with this item such that we can be able to go to the next item. I'm going to ask, we are going to have a school discuss now. Teacher Peter, hope we are Wampeo is set. Teacher Peter, is Wampeo set? Then I've also seen, I think, Moloto High, you are going to discuss for us an item. You can prepare. Teacher Peter, are we set? Wampeo, Ntake, kindly let us know. Okay. Then schools that have prepared to discuss, kindly let us know through the chat. Okay. Okay.
Yes, good afternoon.
Good afternoon, Wampeo.
As Wampeo, we are ready.
Okay. Kindly take over.
Okay, it's okay.
This is one going here and we're doing item 11. It says in Kampala district, the government inspected 100 cars at a local garage to check their roadworthiness. So it will be like the number of submission will be equal to 100. And we have that the inspection will go some common causes of failure. Faulty tires, steering problems, and bodywork faults. So we next, faulty tires B, BF, and steering problem. Steering problems will be the BF, then the bodywork fault will be B. So we come here to the question, it's saying, out of the 100 cars, 36 had faulty tires. The number of F equals to 36. 42 had steering issue. And the number of F will be equal to 42. And I've told her that 30 had the body work problems. The number of three will be equal to that. Some cars had multiple problems. That means that they had the faulty tires, steering problems, and the bodywork faults. That will be the number of F intersection B. Will be equal to, let us name it X. They've also told us that 8 cars had both bodywork and tire faults. No, sorry, 8 cars had both faulty tires and steering issues. The number of F intersection S is equal to 8. 7 had both steering and bodywork problems. Number F intersection B equals to 7. And 12 had both bodywork and tire faults. Number of B intersection F will be equal to 12. Additionally, the number of cars that failed due to other unrelated reasons were 5 more than the number of cars. So these cars never had faulty tires or steering problems or bodywork faults. So they'll be out of our six. They'll be the number of F intersection S intersection B a complement. And they have told us that they are 5 more than the number of cars that had all the 3 problems. So there will be the X that's 5. And then we come to our stage here. This will be a Venn diagram. Showing the number with faulty tires steering problem because you are cold. So remember, we have the summation and the handle. Here, the 100 cards. We also have the number of them. 36. Number of days at 42. We also have the number of snatch. We have those who are older issues. So the video in the middle. We told us that 8 cars had both faulty tires and steering issues. They had both faulty tires and steering issues. So they'll come here 8, but they'll be minus the X. Because they had faulty tires and steering problems, but they might not have had the body faults issues. They also told us that students had both steering and bodywork problems. Steering body or problems. There were 7. So it will all be 7 minus X. But they had a steering body faulty issues, but they may not have had the body tire. Then we also had a 12 had body work and tire faults. The 12, so B 12 minus 8. And then you have this, that's spacing, that's find it. We'll name them. This one's 10, this one is also this. They're going to do our also big. So if you add A plus this plus this plus this, it give us a total set of F, which will be equal to 36. A plus that 12 x plus the x plus 8 minus x will be giving us the 36 because I'm measuring the number of moves there. Will be A plus 12 x, of course, we want to take a negative plus a positive to give us 0. And plus 8 minus 8 will be giving us 36. Will be A, that's like 12 plus 8 is 20. 20 minus x equals to 36. So remember, we're looking for A only. So that means A will remain side and this will be for the other side. That will be A will be equal to 36 minus 20. A positive when it crosses that and equal sign to give us that. We also do the same with B. B plus 12 minus x plus 7 minus x will be giving us that B plus that 12 is equal to this one plus 12 plus 7 minus x will be giving us that B plus 19 minus x will be giving us that B will be equal to 30 minus that 19 plus x. That means B will be equal to, is it 11? 11 plus x. So come and put here 11 plus x. We also find in C, then C, the value of C. C plus the 8 minus x plus the x plus 7 minus x will be giving us 42. C is equal to this one, C plus 8 plus 7 minus x equals to 42. It will be C plus the 15 minus x equals to 42. 2 will be equal to 42 minus 15 plus x. C will be equal to 27 plus x. Yeah. Also come and put it here, 27. So after this, you have many unknowns here, x, and x. So you have to find the value of x. We have also this, that the number of F intersection S intersection B complement is x plus 5. We should go here outside. because we have none of the folds. So if you're finding the value of x, we'll be adding all these to give us the total summation 100 plus all the weeks. So it will be 16 plus x plus 8 minus x plus 27 plus x plus 12 minus x plus the x plus 7 minus x plus 11 plus x plus also the x plus 5 will be giving us 100. From here, we're going to start to collect the like terms. 16 plus 8 plus 27 plus 12 plus 7 plus 11 plus 5, then plus x minus x plus x minus x plus x plus x plus x plus x equals to 100. Let's add this. 16 plus 8. So the total of this is 84. 86. 86. Then start from here. This will cross with this one. Also this with this one. Also this with this one. Remain with the 2x. So 86 plus 2x is equal to 100. So we take this side, remain with the x. 2x will be equal to 100 minus 86. So 2x will be giving us 14. 14 divided by 2, divide by 2. 2 ones by 2 ones, 2 ones, give us 7. The x is 7. After getting the 7, we'll be filling up our sets. Welcome my friend at the list.
Good afternoon. So in this scenario, we have another part that says the district committee discussed that if more than 50% of the accounts have at least two of these problems, then they will launch a district-wide road worthiness campaign to improve vehicle safety. So they said if more than 50% of the accounts have at least two. So at least two means two and check. So if we come back to our first example and more. Also the benefit all of the cards. Don't become an hard. So with that, 8 minus 8 is the 1. 12 minus 7. 12 minus 7 is a 5. 7 minus 7 is a 0. So I know what the child got. the charge both S side. So we have no vehicle attached both S side. So we are going to add these four parts. With that, we have our 1 plus our 5. Then there is a 0. I mentioned the x, which was 7. So the total of this, we have a 13 here. So 13 being important, I want to find at least 2 of the problems. But remember, our universal set was 100. So this is all out of 100. So they say 50%. So we have 30% here. Meaning that the district should not launch a random this campaign because they say if more than 50%, but we have a 13%. So the reason is because the percentage of vehicles that had at least 2 of these problems was less than 50%, and it was 13%. Thank you.
Thank you so much, Wampeo, for the wonderful presentation. I'm going to ask the presenter to first put for us a heading for the Venn diagram. Whenever we are dealing with this section of data and probability, you must be very specific on, okay, very good, it is there. So hope you can notice that is the heading we shall expect, because that heading, dear students, it takes a mark. So they give you a mark for P for specifying the kind of presentation that you are making. Secondly, we expect you to have 2 Venn diagrams, the one with unknowns and then another Venn diagram without unknowns. So after having this Venn diagram with very many unknowns, then have another Venn diagram when you have substituted for all your unknowns. Number 3, I think you can notice how Wampeo was finding its different parts, the values of C, the values of this and this. So please, whenever you're handling such items, make sure you put the subtitles to be specific on what you are finding. Maybe you are finding for F only, I'm finding for S only, I'm finding for B only. Yes, so you must have those different things indicated clearly. But also you notice that when they were starting, they clearly defined and summarized their work. Do not forget always to summarize and have your work well defined. Whenever you are using any letter, as long as that letter has not been mentioned in the item, in the scenario, always define, let B be this, let C be it, let D this. So make sure that's what you call defining the variables you are using. That let F be the fault tires, let this be this and this, such that you can be able to have the marks given to you. Then also don't forget to respond back to the item. Like the gentleman has told us that now in your conclusion, we need to see you comparing the percentage that was given in the scenario of 50% with the percentage you have obtained. So you compare the two, whether they should be able to introduce it or not. But you must back up your conclusion with evidence by showing us the calculations that you have made. Then you go on, and based on what you have within the scenario, the percentage they wanted you to compare with the one you have obtained, that maybe because this one is less than this, because of this is greater than this. Otherwise, thank you so much, Wampeo, for that beautiful presentation. Okay. Next, we are going to have Moroto High. So that was Wampeo Ntake. So we are going to have Moroto High take us through item 10. Moroto, I don't know which camera you are using. Moloto, you may speak to us. We want to be sure which camera you're going to use.
We are coming.
Okay.
Can you hear us?
Yes, we can.
Okay.
Okay, perfect.
My name is Morro John speaking. Sorry. Good afternoon, members. My name is Morro John speaking. A student of Morro High School. Here to present number 10, which reads, a poultry farmer in Uganda is preparing feeds for very different stages of diabetes, starter, grower, and finisher. Each feed type is made by mixing very ingredients, concentrates, broken maize, and maize bran in the following proportions. This 50 kilograms, 57, 36, 50, 67, 39, 50, 84, 45. Now, what essays represent the quantities and cost for each feed type in the structural matrix from a zero analysis. And the equation says from here, the cost of the ingredients per kilogram is as follows. Each kilogram of concentrate costs 4,200 Ugandan shillings. Each kilogram of broken maize costs 1,600 Ugandan shillings. Each kilogram of maize bran costs 900 Ugandan shillings. The farmer has a total budget of Ugandan shillings 5 million available to produce a combination of feeds for the birds during this cycle. So thus represent the quantities and cost for each feed type in a structure matrix format suitable for analysis. So in the first place, we are going to find the feed matrix. So for the feed matrix, we consider only this part. Because this is the part for the ingredients. The matrix will be 50, 57, 46, again 50, 67, 99, 50, 84, and 85. This one is the what? The third matrix. Is it a very by very matrix? In the other hand, we have again the first matrix, which is what? This one is the third matrix. I'm going to the first matrix. Is what? 1,200, 1,600, and then 900. This one is a very by one matrix. So some of our friends may say, why are we saying that this one is a very by one matrix and this one is a very matrix? It is because we are going by row by column, row by column. So here is row by column, row by column, and row by column. So for this one, this is a row by one column. This is a row by again one column. This is a row again by one column. So I think that is part A of item number 10. Yeah, you can see. We go to item B. Considering the current market price and the farmer's available budget, determine whether it is financially feasible to produce the required feed combinations to support the birds grew all very ingredients. So for this matter, we are going to get the cost for these feeds. We are going to combine the feed matrix and the cost matrix in order to get the what? The cost matrix for all these ingredients. So which will be I think this field cannot be enough for us. 50, 57, 36, 50, 57, 39, 50,
Raise your voice.
84, and 45. So, because the first mark is CBC, gonna get the first one, 200, that one is 1,600, and it 900. We are going now to combine all these matrix in order to get what? The cost for these items. So we are going now to multiply these two matrix with the cost. Which is it? 50 multiplied by 4,200 plus 57 times this one. 57 times 1,600 plus 36 times 900. For this one again, row by column. Which is 50 times 4,200 plus 67 multiplied by 1,600 plus 39 multiplied by 900. This multiplied by 4,200 plus 84 multiplied by 1,600 plus 45 multiplied by 900. So I'm not going to work this.
But available your numbers. Like
So this is part A of this. This is part A. So this one is for part B. Okay. So we are going to multiply now this matrix. So 50 times 4,200 plus 57 times 1,600 plus 36 times 900. 50 times 4,200 plus 67 times 1,600 plus 39 times 900. We are going to get, for this one, we are going to get at the very top one, 600. For this one, we are going to get 300, which is 2,000 300. And we add all this. We shall also get 3,000. 300 into 4,900. So we are going to add all this in order to get the total cost for all the ingredients, which will be total cost.
Okay.
Equals to
A minute. It seems there is some concern. We may need first address.
Okay.
Can you just pause a bit? Yes, Muyomba Nicholas. Nicholas. Yes, Robert.
Make sure you raise your voice.
So-
If people are listening to you, don't talk like you're talking to your brother or sister.
Robert. Robert, unmute.
Make sure you listen to the concern.
Oh, I'm failing to get to Robert and Nicholas. I think, teacher, we can continue.
Okay.
when we add, we're going to add now the total cost, which is 3,000. 300 at 3,600 plus 352,300 plus 384,900. When you add, we shall get a total of UGX 1,077,800. So the total cost is UGX 1,077,800. But remember the question is saying, considering the current market prices and the farmers available budget, considering the current market prices and the farmers available budget, determine whether it is financially feasible to produce a required seed combination to support the parts through all the stages. But remember, the farmer had a total of Uganda shillings 5 million.
Camera sometimes.
But the farmer had a total of Uganda shillings 5 million. So this total budget was for what? For the feeds. So, but from our calculation, we have got a total of Uganda shillings 1,070,800.
Yeah, hello. Thank you members for my colleagues, for the previous colleague that has presented. It was all that nice, but allow me to send my greetings to my colleagues in the DS and also our neighbors in Kawan SS and those from the back. Let me continue from where my colleague has ended. That one is we are still in part B, and of which we are, my colleague left some bit of the cycle, which is total. We are getting the total amount of money spent on feeds. Total amount of money spent on the feeds. Yeah, that is it now. My colleague has done everything, which is all very okay. As you have seen, even the total cost, he has done it in the right way. Now, they are saying, considering the current market price and the farmer's available budget, determine whether it's financially feasible to produce the required combination to support the birds through all the 3 stages. But McHugh, our brothers, when you see it, here is like the total amount of money budgeted for buying or for purchasing the feed, it is 5 million shillings. But now, the farmer has spent the total amount of money, which is 1,770,800. But when you compare 5 million and 1 million and 1 million, this is the budgeted amount of money. And that one, maybe to make me to clarify to you guys, the total amount of money spent, total amount of money spent for purchasing feed is called $1 shillings, 1 million, 7,800. Now, when we compare, is it feasible for him? Is it feasible for him to produce the required feed combination? Yeah, market will see it. 5 million, which the budget is for buying the feeds, it's much more than the amount of money that he has spent. Now, when we conclude, therefore, it is feasible for him, therefore, it is feasible to produce the required it is feasible for him to produce the required combination to support the birds through all the stages. Because we are now justifying, because the total amount of money, which he budgeted for is more than the expenditure. Hello, members, we are done with this, and we are still continuing. Now we are going to switch. We are going for part 6. Part 6. The question is that given the anticipated 50% increase in the cost of all ingredients in the next stocking season, estimate the adjusted expenditure the farmers should plan for to maintain the same feeding cycle. Given, let me repeat the question for you guys. Given the anticipated 55% increase in the cost of all ingredients in the next season, estimate the adjusted expenditure the farmers should plan for to maintain the same cycle. Now, our subtitle is going to be adjusted expenditure. Now they're saying it was an increase of 5%.
Raise your voice. Yeah.
Increase of 5%, which is equal to 100 plus 5, which will give us out of 100 times the previous amount of money. The previous amount of money that is spent on purchasing the kit, which is gonna shillings 1,070,800. Now when you cancel this one, you cancel this one. Now we shall say 0.5 times all this is UGX. Now my brothers, whatever you want. What I'll do with some cup.
Follow it. Tell him at your plans.
Yeah, I'm still the Islamic of application here, which is called to UGX 1, 1, 2, 4, 0.
Raise your voice. Very important.
Yeah, this is the amount of money is spent after an increase or adjusted expenditure of 5%. Now, this is the amount of money. Therefore, now we shall conclude as it is one of the vital things, as one of the vital things in mathematics format. Conclusion, it is a must and it is fair, and if you answer for it, a mark. It's not a matter of you getting the answer. Now everything goes on that no, you will miss one of the marks. Now, therefore, the farmer should plan for let me pass because if so UTX they are vital for you to mix them. They will deny for you a mark, and which is very bad. Therefore, you should plan for Ghana shillings 1,124,340 shillings. To maintain the same cycle. My brothers and sisters, your comments are all allowed. Where unnecessary, you can also correct us. We are not 100% accurate. Yeah, that is it, and it's very okay. Allow me to wish you a good day as you have already presented our item. All the comments are always come. Yeah, all my brothers and sisters, it's all of good and mesmerizing for us also to be part of this and allow us as the body of MHS to give regards to all who happens to be in this session, those of the moderator, Kasuba, and the rest of our colleagues who are in us, but allow me to say thank you.
Okay, thank you so much, Moroto, for the presentation.
Let's go back.
Thank you. I know those who may have some questions you may ask.
Oh, we wait for questions. No questions, because if there's a question, you have to clarify.
Any school that has a question? Okay, I think there is no any question. There is no any question. Okay, that is very important and that is okay. So thank you so much, Moroto. Muyomba Nicholas. Muyomba, unmute.
Just a moment.
Hello,
Muyomba, you may ask.
I was waiting for the scenario they were attempting.
Oh, Muyomba, the scenario the questions have been posted in the chat.
Okay, thank you.
Check in the chat. The scenarios have been posted there. Okay. Kongura.
Thank you, everyone.
Yes.
My name is Chan Ogorara Vasco. My question moved to the last part.
Okay.
Because from there, they're saying the increase in the cost of all the ingredients. But if you have to look at what they calculated there, they use the total cost now to compute for the increase, the unparticipated increase of 5%. But my question is about now, if someone use the increase of that 5% to each and every cost of the ingredients, would the person also be in the right position to get the final result? That is my question.
Okay, thank you. Yes, can you answer?
Answer. One person.
Okay, for that. That is also okay. And you want to get the same amount. For the starter, you get the amount. Let it for you. They are saying the increase of 5. Multiplied by the amount of dollars. 200. Cost of 200. You remove 0 and 0. You remain 105 times 42. When you multiply, you will get cost of 110.
for the starter.
Grower. The same thing. 100 5 over 100 times 1,600. We're not sure. 1,600.
I'm going to ask a teacher. Let him just tell us briefly about the expectation, not to calculate everything because of time.
It's okay.
Okay. For this, okay, next presentation is
Tell us the expectation.
Expectations.
Don't just give us the expectation. Don't calculate. Just tell us.
Total amount for the starter. You are going to get 100 is it?
You are not. You tell us. Explain. Just.
So the question is asking us that for each data type, you are going to multiply this percentage increase with a total of each data type in order to get the what amount of money to be spent to that fit. So the answer you will get will be the same as the answer we got from there.
Okay, thank you so much. That is correct. Now, when you look at the two approaches, all the approaches will lead you to the final answer, like the gentleman has explained. But one thing now you need to do, always you need to plan for your time. You have noticed that in this calculation the gentleman was doing, you have to first calculate for the starter, grower, and finisher. Then after put them in a matrix and then make the calculations and the rest of that. So you notice that it might take more time compared to someone who used the other total they had obtained. But at the end of the day, you will get the same answer and all of you will have to get the same scores. So it is very fine. Unless when they had specified on a particular approach for you to use for that particular number. But in case they had said still using or maybe using matrices and something like that, then that would be another case.
So thank you for the correction.
Okay, thank you. Let us pick one more person. Newagwine Emmanuel.
Another question.
Good afternoon, sir.
Good afternoon to you.
Yeah, for me, I've been wanting to ask, what is another term to use to say like the adjacent expenditure?
Adjusted expenditure.
Expenditure, yes.
Okay.
let me answer.
Okay.
That just the expenditure. Oh, it's the same as increase
Or decrease.
or decrease. I mean increase or decrease. That is what you mean. Thank you.
Okay, thank you. Yes, other times they can use the word revised, modified. Yes, so they can use such words to mean the same. Revised, modified. Yeah, all them mean the same. Or sometimes even they can use amended. Yeah, something like that. Okay. Yes, Wampeo. Wampeo, you have a question? It seems we are failing. Yes, Wampeo. Oh.
Mr. Kaziba, you excuse us.
Okay, okay.
I one of my students is asking, doesn't the type of brackets have anything to do with the matrices? Because they used some type of matrices which is not the one that we normally use for matrices.
Tanak, you can explain for them that one.
So for the case of brackets, all these brackets mean the same. There is no need for you to specify. Even if you do it in this way, it is the same. There is no problem. Even if you do it in this way, there is no problem. So that's it. That's it. Thank you.
Okay, now the first type, we call them the square brackets, and those are the most common one used outside Uganda, the square brackets. And then these ones we mainly use here are the parentheses. Yes, but all of them are okay. But the common one here we use in Uganda is this second one of parentheses. But there is no any penalty for using the square brackets. Yeah, but all of them are okay.
Thank you.
Thank you.
Okay, then Queen of Peace. Queen of Peace, I.
Good morning. Good afternoon, members. I would like to ask that are we allowed to cancel our work, like when we are calculating? Because I've seen many of other presenters canceling the work. Are we allowed?
That is for the calculator.
So for the case of canceling the work, you may not cancel the work because it will look very tight. Maybe just if the number is like 4 out of 7 multiply by 28,000. For you to make it very neat, there is no need for you again to cross your work because it will look dirty. Maybe you just leave it like that. You only put your answer for it to be neat. Thank you.
Okay. Thank you. Thank you. Okay. Now that kind of counseling that you are talking about, surely there is no need for you to show how that 7 goes by this, 28 goes by that. Yes, as long as here you can continue and show us. But I know sometimes it's because people do not have calculators. Sometimes it is easy for people. Yes, but make sure if those people who are doing such, in case that is your main step of reducing, first write another step where you want to cancel, or you can do it as side work without necessarily canceling, because you may reduce on those steps, yet it was your major step. So many times we encourage you not to cancel, but for you continue flowing with your work as long as you know how the reduction works. St. John's Kabwoko. St. John's, ask.
Question is that what if you're starting to calculate and the letters represent the matrix? Are they necessary or not?
Okay, you wait. You'll get comments from there.
Okay, now when it comes to
for students where they are presenting from.
Okay, now when it comes to letters in the presentation for matrix, if you are going to use them, they can be very good for simplifying your work. Now, but when you decide to use a letter, define it that let A represent this and this. Let B represent this and this. Let C represent this and this. For whatever letter that you want to use, make sure that it has a representation. And here we encourage using capital letters, that let matrix A be represented by, let A be, yes, something like that. But in your calculation, like I guided earlier on, those subtitles are very good for guiding you. That now I'm calculating this and this. That now I'm calculating this and that. So that would be the ideal thing or the best thing in case you are not going in with the letter approach. There is no need for you to write in words. There is no need for you to write in words the amount. The figures can as well work. Queen Joy. Queen Joy.
Now, sir, how can I get the items?
The items have been sent in the chat. Kindly check through. All those items are there. Nyalukika High. Nalukika High, unmute. Okay, I'm failing to get Nalukika High, though I'm seeing your hand up. Nalukika High, you can ask. Nalukika High. Okay. Kangole girls, please kindly prepare. You are the next. Then from Kangole, we shall go to Bishop Dunstan. Okay, I think I'm failing to get Naluchika. Then lastly, St. John's Kawoko. You have another question, I think. St. John's Kawoko, I'm seeing your hand. Unmute. Okay, I think yes. Now, someone has asked, what do you base on the first site for the questions? Now, I'll ask you that get familiar with the elements of construct. Now, take an example. The item we have done, you will notice that it falls under the element of construct number 3, under data and probability. And under data and the probability, I think let me share my screen a bit here. Under data and that, okay, I'm going to share my screen shortly. Yes, now the item we have been dealing with falls under data and probability. That means that when that item appears in question 4, or when it is your, let me say it is your question 4 or question 5, sorry, item 3 and item 4. In case you find it under item 3 or item 4, it means that we are dealing with element of construct number 3, which is about data and probability. Now, the expected approach to be used is the matrices. Now, for you, you relate, you ask yourself, can I use Venn diagrams for an item? That no. Can I use statistics? That no. Can I use tree diagrams? That no. That the best approach now that remains is the matrices. Because under data and probability, the major things we have is statistics, Venn diagrams, matrices, and then the tree diagrams. So you look out for the best approach to use. And therefore, even we expect you to have a heading that now I'm using matrices. So have your heading that I'm now using matrices, because when it comes to data presentation, you need to specify what are you using. Are you using Venn diagrams? Are you using tree diagrams? Are you using matrices? Which one are you using? So you specify for us that I'm using matrices. And you know that when it comes to matrices, there are things that are very important. And one of the things that you should not forget is the data summary. When the data has not been summarized for you, please go on and summarize your entries. Number two, look at the title, the heading that matrices for this and this. And I've clearly, and I want to remind you, always have subtitles for whatever thing you are doing, that I'm calculating for this, maybe calculating this and this, doing this and this. Then make sure you conclude, have a reason for what you are doing. So conclude with a reason and make a decision. Sometimes in case the decision requires you to say yes, then back it up with a reason, but make sure that you have quantitative data. You have the digits, the figures to back up with your working. Now, where need be, sometimes you may find that you are using units, that you need units. Please include the units because they may ask you the number of kilograms, the number of this and this. So for such cases, make sure you include the units for whatever quantity you are finding out. Make sure you show clearly your working. Do not jump steps. Some of you, I know you are very, very smart. You have a matrix. Take an example, you have made your calculation very well. Let me say this is our matrix. I'm just giving an example. This is 3, 4, maybe 1. For you know very well that when we are dealing with matrix, we multiply a row by a column. But some of you may just come and say 3 times 3 is 9 plus 1 times 4 is 4, 1 times 1 is 1, 4 times 3 is 12, 4 times 4 is 16, 4 times, then you just do like that. Now here you notice that you have jumped a step, and the step you have jumped here is the one that shows us that you multiplied. So clearly show the step that now I'm multiplying 3 times 3 plus 1 times 4 plus 1 times 1. Avoid jumping steps because sometimes that step you are jumping, it is the one that is crucial. You may never know it is the step that is going to be awarded. So show all your steps clearly. And I repeat, write your work going vertical, such that someone who is going to mark your work may see your work very organized, such that he can be able to put the scores that this is manipulation, this is a mark, this is what? A mark. So show your things clear. Even if you reach here the conclusion, let me say you have this, something like that, and you have to conclude that you have a conclusion that where you must add. Please, you showed your things when you are adding them, that this is 14, maybe plus 30 plus this. I'm assuming, I'm assuming, let me say, this is 2, let me say something like this. So in case you are getting the total, show all these 3 items that you are adding and then put the what? The total. Avoid jumping steps and stick to the strategy that you have chosen. Those things of jumping steps, you don't know because you are not the person marking yourself. You don't know which step is crucial. So you may miss out on the marking points. And therefore, dear students, make sure that some of these things are on your fingertips. Addition of matrices, subtraction of matrices, and then multiplication of matrices. Remember, whenever we are dealing with the matrices, you need to know, mainly when it comes to multiplication, rows and columns must match. So make sure that before let me give an example. When you look at this matrix, this is, I'm just using this and I'm using this. I want to give it, when you look at this matrix, this is a 3 by 3. When you look at this matrix here is a 3 by 1. For any matrices to be multiplied, or we call it compatibility, you look at the number of rows in the first matrix and what the rows and the number of what? Of columns. They must match for the 2 matrices you are matching. When you look at this is a row and this one is a column. So you need to look at this matrix. When you look at this matrix, this is row 1. Look at this one. If you can multiply them, you look at this digit can match with this one. Row by column, row by column. What do you need to look out whether the matrices can be multiplied? Look at the rows and look at the columns. And how do you know the result? For any two matrices to be multiplied, dear student, in case this is the first matrix and this is the second matrix you are dealing with, always these two must be the same, those two things. If you find that these two are different, it means you may not be able to multiply those matrices. And the result of the matrix you get is what remains, this one and this one. When I have, let me say 2 by 4, and I have another matrix 4 by maybe 1, whenever I see that these ones are the same, it means I can be able to multiply those matrices. And the result will be a 2 and a 2 by 1. So please always check out whether those matrices can be multiplied. Take an example. Should you have your matrix, let me say you have 3, 4, 1, and you have another matrix 4, 2, 3, 4, 1, 4. Let me see, these are the matrices. When you look at this matrix, this is a 1 by 3. When you look at this second matrix is a 2 by 3. The moment you notice that these are not the same, it means you cannot multiply those two matrices. Now, should you write like this, and then for you go on and do your forgery of your work and you multiply thing, this first step, as long as you have, it shows that you have, the matrices can't be multiplied, then it means that at the, you cannot be scored, because this one can't yield the right answer because the matrices are not compatible. So that means that they will not score you because this one is already wrong. You can't multiply a 1 by 3 multiplied by a 2 by 3 because the columns and the columns of the first matrices do not match with the rows of the second matrix. So you need to be well conversant with how you arrange your matrix such that they can be multiplied well. So make sure you arrange them well to avoid challenges. But the only thing you need to know that when I have A times B as my matrix and I have M times A, as long as these two are the same, then it means I can multiply my matrix and the resulting matrix will be A by N. Okay. Okay. I'm not okay. I think it is okay. Now can we have Kangole girls? Are we set, Kangole? Kagole, is it Kagole? Kagole, are we set? Okay, I'm not seeing them on. I'm not seeing them, I think, on. Okay, since they are not on, we are going to go on to the next one. Bishop Dustin. Bishop Dustin, kindly unmute. Bishop Dustin. Okay, I don't know. Muyomba Nicholas. Bishop Dustin. Kindly, I want. Yes, Bishop Dustin, yes. Okay. Okay. In a school that is ready, you can kindly indicate in the chat such that I can be able to see you that is ready to present as we get Bishop Dustin. I want to know the gadget the teacher is using to connect. Global Eden. Okay. Okay, I think I'm failing to get them. I'm failing to get them. Do we have a school that is ready that wants to discuss something with us? St. Mary's Ediofe or Selele Girls? Vora SS. I think yesterday I wanted to discuss something. Oh, okay. Bishop is using Ronnie Rico. Okay, let me get it. Okay. Ronnie Rico, kindly unmute and have your camera on such that you can connect us to Bishop Dastan. Ronnie, you can unmute and have your video on such that we can be able to connect. Okay.
I'm seeing. Thank you.
Yes. Meanwhile, Saint Popo Anak, please prepare. Popo Anak, prepare a question as well. Okay. Okay, presenter, raise on your voice. Okay, teacher, we can have, can we have the other microphone switched off for the other gadget?
Okay.
Hey, for the other gadget?
Yes.
Okay.
Hello. Bishop Dunstan.
Okay, clear.
So I'm Martin Chubes from Bishop Dunstan, Suga Memorial Secondary School, Kalangala.
Wait.
And we are presenting item 4. So a furniture.
You go on.
A furniture manufacturing company in Uganda produces tables and chairs for local schools and offices. Producing one table costs 50,000 UGX and requires 2 labor hours, while producing one chair costs 30,000 UGX and requires 3 labor hours. A company has a weekly production budget of 2 million and can utilize up to 150 labor hours. Each table is sold at 90,000 UGX and each chair is sold at 60,000 UGX. So the first task is asking, express the production constraints as inequalities and equations. So we are going to express the production as inequalities and equations. So first of all, I'm going to use this. We are going to first relate our tables and chairs because we have to first identify what exactly do they need. And we can mainly identify it from, if you read all of the questions. The second question is asking, present the feasible region determined by the constraints on a Cartesian plane. Then the third one is saying, determine the number of tables and chairs the company should produce in a week to maximize the profits. So I can identify here that they mainly need the number of tables and chairs. So that's where I'm going to read from. I'm going to say, let the number of tables and chairs be X and Y respectively. So after letting, now I'm going to use a simple table in order to get my equations simply. So I'm going to put here, we have the tables. We have the tables and we have the chairs. So I'm going to do like this. Then here we find what do they mainly need. They need so here I'm going to put the cost of each table. It's cost of each table. Cost of each, not cost of each table. The cost of each, then here we have the bars, and then here we shall have the how much each is sold. I think it's, let me call it the selling price. Then after there, I'm going to separate here, I will call it my total. I'll call it my total. So now I will use my, let me put these hours here and the selling price here. So this is the cost of each. So I will read while answering this table. So I will say, a manufacturing company in Uganda produces tables and chairs for local schools and offices. Producing a table costs UGX 50,000 shillings. I say the cost, the production costs here I have 50,000 UGX, and it requires 2 labor hours. There are 2 hours. So they say, and they are saying here, producing 1 chair costs 30,000, and it requires 3 hours, 3 labor hours. So I'll put my 3 there. Then they're saying the company has a weekly production budget. That means the total of this, a weekly production budget. This is the production of each, but a weekly is, I will put, they are saying it's over 2 million. And it utilizes up to 150 labor hours. It utilizes up to 150 labor hours. So they are saying each table is sold at here, our selling price. We are going to say each table is sold at 90,000. And each chair is sold at 60,000. Then, after summarizing my table like this, it's very easy for me to remove my inequalities from this table. So, we are going, remember, we should be very curious on the words they use, the at least, at most, and the others. So here, we are going to read as well. Now we are formulating the equations out. So they are saying, here, as we see our question, the words are not mainly used. So what we are going to say, a company produces, has a weekly production budget of 2 million. That means that company does not exceed 2 million. That means, which is meaning that it may be less than or equal to. So we are going to say, the first equation will be, we are going to connect it to what we related on tables and chairs. We said tables are X and chairs are Y. So we are going to say 50Y, 50,000 X plus 30,000 Y will be equal to the 2 million. So it will not be equal to, so we'll go back to the question. They are saying a company has a weekly production budget of 2 million. That means it may be less than or exactly equal to. And we say which is less than or equal to 2 million. So are you seeing now how easy it becomes to remove our inequalities? So we go to the next one. We have this one of hours. We are going to use Andy can utilize up to that means it does not exceed. It can use less than or exactly equal to 150. So we are going to say the hours. It will be 2x plus 3y will be less than or equal to 150. So that is our second equation. And then we are going to remove the third one, this one of the selling price. And this one will help us to find how you can maximize our profits. So there we are going to say, we remove it from there. We are going to say 90. It's 90,000 X plus the 60,000 Y will be equal to will be there saying each is sold at this will be equal to the selling price. So we have now 3 equations. You don't have to forget our equations that have to be there, which we have one of them. We have x is greater than or equal to 0 and y is greater than or equal to 0. So we shall add them. Our x is greater than or equal to 0 and y this is less than. And y is greater than or equal to 0. So I think before you go further, anybody who may want to ask a question or correct us where possible, we are welcoming. Yeah. So anybody who may want to correct us where possible or a question, I think let me give a chance to my fellow to answer part B.
Yes, I see that.
Do they think the selling price of objective formula?
It is the selling price.
You go.
So, my name is Segawa David, and I want to first congratulate my colleague, Chigozi Koyam, for this work of dating the inequalities. So, I'm going to handle part B of this question. Part B of this, which is saying that represent the physical region determined by the Cartesian determined by the constraints on a Cartesian plane. So to determine the feasible region, you have to first get the equations, the inequalities which are projected here. So allow me to remove this data and we go on. So we want to get the feasible region on a Cartesian plane. So to get the feasible region, since we are having our inequalities, which are things. So we are having this equation, this inequality of the cost price of the costs, this inequality of the hours, and this one of the selling price. So to get the feasible region, first of all, we have to get the coordinates to use on a Cartesian plane. So how are we going to get the coordinates? How are we going to get the coordinates? First of all, our graph, like for example, a graph used by National Examination Board, it is not very wide. So according to our qualities, we are having large figures. So we have to get a common divisor to reduce on the figures. So how are we going to make it? Like for example, on this, so when we are dealing with a Cartesian plane, try to remove these lines and equate it, like as I've done. So we are going to get a common divisor, which is going to suitable this. So yeah, we are going to get here we are going to get 5x plus 3y is equal to 200. It is 200. So we are going to get the coordinates. And to get the coordinates, we are having x and y, whereby our x, let me say that when x is 0, we substitute it in our equation. Plus 3, 1. So when x is 0, our y, this is 0 plus 3y is equal to 2.
So we are going to divide by 3. By 3. We are going to get, so allow me to divide this board because it is small, but in the paper it is not to be like this. So our answer will be, our answer is going to be, it is 66.6, 0.66, 0.66, it is recurring. Eh? So when, so the coordinates, when our y is equal to 0, we substitute it plus 3y is equal to 2. So it will be here 5x plus, we substitute 0. So is equal to, we divide. So our x is going to be 40. So the coordinates we are having are 0, 0, 6, 0.666, and 40, 0. Whereby this is going to be our x and y, here x and y. Okay. We go also on this equation. This inequality, it is 2x plus 3y is equal to this is our x, this is our y. So when our x is 0, when our x is 0, substitute it in the equation. So our y is going to be what? Y is going to be defeated. So when y is 0, you substitute it in the equation, x plus 3, y is equal to 2x is equal to x is going to be, so our coordinates, this is 0, and this is repeated. When this is it? Yeah, it is 75. So okay, I'm sorry. Here we are having 1. Okay. So we've got our coordinates to use on the Cartesian plane to get the feasible region. So allow me to remove this data. So the coordinates we are having, 0, 0.666, and 40, 0. We also have 0, 50, and 70, 50. Okay, we've got the coordinates to plot on our Cartesian. Please don't forget to write the inequalities before you draw a Cartesian plane. Like for example, we are having 2 towards yeah 2x plus 3 is equal to then this 5x plus 3y, is it? 3y is equal to 200. Other equations where x is equal to y is equal to so on our Cartesian plane, let me assume that this is my graph. This is our y-axis for x is equal to 0. Since this is our 0 on x-axis, here is so we need a graph, but remember, they have told us that we want a feasible region. And to get a feasible region, we have to be having the wanted region and unwanted region. Due to that course, we have to get the wanted and unwanted region by testing these coordinates. So, let me first, I'm going to use a scale of 10. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is 10, 20, 30, 40, 50, 50, 60, 70, 80, 90, and this is 100. So my scale is on a vertical scale, it is 1 centimeter representing 10, and on horizontal scale, it is going to be, sorry, it is 2 centimeters according to, because I'm focusing more so on a unique graph, a standard graph, whereby we are going to use two squares. 2, 2, 2, 2, 2, 2. Okay, on the horizontal scale, 1, 2, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. I'm going to use a scale of 10. 20, 20, 30, 40, 50, 60, 70, 80, 90. So on our horizontal scale, 2 centimeters also represents. Okay. Okay, we start plotting. This is x, y, x, y, x, y, x, y. On our x it is 0, and on y it is 66.6. Let me just assume. We are also having 40 on the x-axis and 0 on the y-axis. To get your ruler, so to determine whether this is a bold line or solid line, we originate it from the equation. So if the equation was having like equal signs, like greater than, less than, or equal to, we use a solid line. But if the equation was having just less than, we use a dotted line. I'm sorry for having a small board, but I illustrate all that we shall follow. Okay. This is 0. And please don't forget to name this line, because this was 5,000, 50,000 x plus 30,000 y is equal to 2 millions. Okay, this is 0, 50, and 75. Let me estimate 75, 0. This is also a solid line because it is having equal, greater than or equal to. Don't forget to name this line is 2x plus 3y is equal to. Okay, according to our equation, we are going to shade either a wanted or unwanted region. We also have x is equal to 0, y is equal to 0, which are indicated here. Y is equal to 0, x is equal to 0. So allow me to test so that I can get the wanted or unwanted part. Just allow me to subsidize my blackboard. Okay, let me start with this. I'm going to use the text point, which is use 0. Okay. 0. This is x, this is y. So 5x plus 3y is equal to 200. So our x is 0 and y is greater than or equal to, right? Okay. 5 times 0 is 0. 3 times 0. So it will be 0 is less than or equal. 0 is less than or equal to. 0 is less than or equal to 200. So according to this, it is correct. So it is true. Because 0 is less than 200. So it is true. If it is true, since we have used our test point of 0, 0, whereby our x is 0 and y is 0, on the side where there is 0, 0 as our test point, if it is true, this means that this is our wanted part. We are going to shed any wanted part. Okay, we also test this inequality. We are going to also use a test point of 0, 0, whereby this is xy. We substitute x plus 3y is less than or equal to 150. Okay, we substitute this is 0 plus 3, 0 less than or equal to. So times 0 times this also 0. So 0 is not equal to 150. According, this is also true because 0 is less 5, 150 is also true. So if it is that the side where is 0 as our x and y is also 0, this is this point. If it is true, we are going to leave this side where is 0, and we shed the other side, which is unwanted. We're done with this. We're done with this. We go to x is equal to 0. X is, and the bit was x is equal to 8. X is equal to 0. You want to add and you wanted side x is equal to 0. Is we want to see equal to 0. So we are going to shed this side. Y is greater than or equal to 0. It is also true. We are going to shed this. Yeah. So I think I'm done. The feasible region. I'd like to welcome my take us in part C. Thank you very much.
Hi everyone. My name is Nachumi Gloria from Bishop Dunstan. I'm going to attempt item 4, task C. The task says, determine the number of tables and shares the company should produce in a week to maximize the profits. If you are going to attempt this item, you must be having this feasible region, whereby you are supposed to use the coordinates from your graph. Before we wrap off this data, allow me to first choose the coordinates we are going to use. If you drew your graph on the accurate graph paper, at this point, you should be having a coordinate here. This point where you're seeing this 40. At this point, here you should be having 15, and here you should be having 40. Also, at this point, here and here, you should also be having, this is 30, this is 20. Should also be having coordinates. Let me hope that everyone following is writing down the coordinates. Also at this point, we are having here 30, and here I'm seeing here also you can be having which is 30 and maybe 25. 30 and 25. Let me hope that everyone wrote the coordinates down. Allow me to wrap off this data so that we proceed with our number. Here the coordinates we got 10, sorry, we got 15 and 40.
Request somebody who has shared switch on. So we are just requesting for somebody. It's back. Thanks.
Here are the coordinates we choose from, have got from our graph. We have 40 and 15. We are having 20 and 30. Also, we have 30 and 15. Those are the coordinates. Before we proceed, since the task is telling us to determine the number of tables and chairs the company should produce in a week to maximize its profits, we cannot proceed with attempting the question before we know the profits made on each table and the profits made on each chair. So let us first find the profits made on each table and the profits made on each chair. Here, we are going to use the price. Here, profits. Profit on each table. Profit on each table. I'm going to use the price of a table. UDX UDX 90,000 and cost of a table, which equals to UDX 50,000. We are going to subtract the cost from the price in order to get the profit. Profit from a table. It will be equaling to 90,000 minus 50,000. We are going to get UDX 30,000. 40,000. That's the profit got from each table. And we are going to get the profit got from each chair. Profit on a chair. We are going to get its price of
price equals.
Okay. The price equals to UDX 60,000 and its cost equals to UDX 30,000. Therefore, the profit of a chair equals to UDX 30,000. This is the profit from each table and the profit from each chair. In order to proceed, allow me to remove this data. Let me think that everyone is having the profits as you have calculated them. Those are our profits. We are going to use these coordinates we got from our Cartesian plane to determine the maximum profits that a company can obtain per week. But remember, to get this, we are going to get the profit from a table, profit from all tables, whereby our tables, we name them to be X, plus profits from all chairs, which are Y. Here we are going to get the total profits using this formula here. And we are going to first begin with this coordinate 40 and 15. We are going to replace our X with 40 and our Y with 15. This is times 40 into brackets plus 30,000 times 15. It will be equaling to our profits, but we do not know the profits. But if you put this in your calculator, you'll be getting profits of profit. The profit will be equaling to 1 million point, it is UGX.
Million 60.
UGX 1 million
60.
60. It is 1 million point 8. That is the profit you are getting from these coordinates here. Now we are going to try other coordinates. We have the coordinates of 20 and 30. We are going to replace our X with 20 and our Y with 30. Whereby we're going to have 40,000 times 20 plus 30,000 times 30. This is going to give us the profits. If you put this in your calculator, you'll be getting we are having the 30 and 15. We are going to replace our X with 30 and replace our Y with 15. We are having 40,000 times 30 into brackets plus 30,000 times 15. This will give us the profits. Therefore, the profits will be equaling to here we are going to get UDX 1.7 million. And here we are going to get UDX Ah, 1.6, 1.5. That's our amount I have got there. Dear members, after replacing your X and Y with these coordinates, then we are going to compare according to the profits we have got. We are having these profits here and these profits. To get these profits, we use the 40 and 15 coordinates. To get these profits, we use the sorry, here we did a mistake. Yes, we did a mistake, sorry.
Is it like that?
Yes. These coordinates were 40 and 15. The next profits, we use coordinates 20 and 30. Here, 20 and 30. And these last profits, we use coordinates 30 and 15. 30 and 15. Therefore, as you're seeing, here I have got 2,050,000 shillings. Here I've got 1 million.7. Here I have got 1 million.65. As we are comparing, we are seeing that these profits are more higher than the rest of the profits we have got. Therefore, as the task is telling us to determine the number of tables and chairs the company should produce in a week to maximize its profits, it's better for the company to use these coordinates, this number of chairs and tables in order to maximize its profits. And you have used these coordinates. And as we are concluding, we are saying that therefore, the company should produce 40 tables. These are tables. The company should produce 40 tables and 15 chairs in order to maximize its profits. Thank you. If anyone has a question, can raise up, or any addition on the number, you can add something.
Thank you. Thank you so much for that great presentation. Allow me to share my screen a bit. More so on that part for the graph. I'm going to make some few remarks such that we are on the same page. Now, this when you look at my screen, this is a graph for that number that was done by Daniela Joy. It looks like this. Now, when I look at the point the presenter has obtained, which is 40, and I think it was 15, if I'm not mistaken, it is a point around this part here. And when you look at that point, it will show you that it is within the other region. But what might have brought it, what the presenter has obtained, one of the reasons as to why he's getting a point of that nature, it is because of the point that he went on to plot. There is somewhere where he had, I think it was 60.66, something like that. So sometimes when you meet points and it is what you're going to plot, your level of accuracy always will be interrupted a bit. And what do we encourage? That whenever you are dealing with an equation and you notice that that equation, when you are using the intercept form, you notice that when this is our x and this is y. When our x is 0, you notice that your y, you'll have 3y is equal to 200. And when you try to divide by 3, you'll notice that you'll get a point 60.6667. Now, plotting such a point sometimes may not be easy for many of us. And what do we encourage? For such cases, we request or we encourage you to create at least more points such that you have many points along the line that you are going to plot, such that the level of accuracy for the line you are going to draw is increased. Because you notice for y, it was okay. When y was 0, you had 200 divided by 5, which was 40. So this point was very okay to plot. But this one for a point, we always encourage that increase on the number of x value. You can come here and say, when x is equal to 10, when x is equal to 20, such that you increase on the accuracy level. That is my point when it comes to the points. So mean that when you say when x is 10, you'll come here and say now this will be 5 times 10 plus 3y is equal to 200. So you are able to have at least a number of points that you can plot such that, so here you notice you have 3y is equal to 150, and when you divide that, at least you'll be able to get something like 50. So you notice that at least here you have quite a number of points that you can base on when you are plotting. So thereby improving on the accuracy. So dear students, at least make sure whenever you meet a point, increase on the what? On the number. So the point of 4 and 15, that one, I think even the board that we're using didn't bring it out very, very well. But when you do it on a graph, 4 and 15 will be out. So that one, we shall not be able to consider it. When you look at 15 and 40, I think in case it is 15 and 40, 15 and 40, this is 15 and 40 is somewhere here. So meaning that 15 and 40 can work very well. 15 and 40. But also when you are very critical, those who are very critical, and you look at around 39, 17 and 39, that point there of 17 and 39, I don't know where it is. I know it is somewhere here, 17 and 39. You notice that the amount of money you get is more compared to what you get when you have 15 and what? And 40. But I think the presenter meant 15 and 40, if I'm not mistaken. So it was 15 and 40, but 40 and 15, this one cannot work. Okay. Then, but here, as we shall look at different answers, but those who have 17 and 39, that is the most accurate answer compared to the 15 and then the 40. Then what other things are very critical when it comes to our graph work? Other areas that are very critical, your heading is very important. You tell us, what does your graph show? That your graph is showing the feasible region. Number 2, labeling. Please and please label your graph that these are the number of chairs, these are the number of what? Tables. You label that this one is the line x is equal to 0, this is the line y is equal to 0. Label your equations that this line is this equation, this line is this equation. And do not forget, always put equal sign. Never put inequalities members and write 2x plus 3y is less than or equal to 150. We do not put inequalities on the graph. This one is not correct. So don't put inequalities, and make sure you do shade very well and you make your work very organized. So your work must be very organized. Indicate also the scale. Do not just put things and you leave. Tell us, what does the scale mean? That 1 centimeter represents 5 chairs. That 1 centimeter represents this number of tables. Something like that, such that your work is very clear and someone marking. And please let your scale be consistent with your scale. Like you cannot, this is 0, 10, 20, 30, 40. Do not have 0 here. Here you come, you put 10. Here you put 30. Here you put 40. Here you put 60. This one means that your scale is not going to be consistent. And whenever your scale is not consistent, you are going to miss about 5 to 6 marks. You are going to miss a mark on plotting and drawing your lines, a mark for shading, naming lines will be wrong, correct feasible region will be wrong, conclusion will be wrong, the table will be wrong. So you'll miss out a lot because of your scale not being consistent. So make sure that for anything you do concerning linear programming, make sure you are consistent with the scale you are using. Make sure you extract the inequalities very well. Then as someone asked, I saw one of the comments, this particular question asked us to find the inequalities and the equations. So we expect that a learner will give us the inequalities, like she gave them to us, that may be 2x plus 3y less than or equal to maybe 150. Then you give, after that, you can write down here and say, now equations. Equations, remember now we expect equal sign. So you have 2x plus 3y is equal to 150. So you give us all the equations for those given inequalities. Now, sometimes they use the word has, that this company has this amount of money. Now, whenever you find the word has, it means that that is the maximum amount of money. When I say that in my pocket, I have 50,000, it means that that is the only amount of money I have. It can't be beyond that. That is the maximum. So for such a case, because that is the only thing you have, it means you'd use less than or equal. That is the amount that is available. It can't go beyond that. That is the maximum. So that one calls for you to use an inequality of less than or equal to that, because that's what you have. It can't go beyond. So please, whenever you meet such, make sure you do it. Then when it comes to extracting the points, always when it comes to extracting these points for you to use, make sure that at least you have at least 3 points that you are going to use for you to be as your optimal points. Don't use 2 points and stop there. At least 3 points are good. And those who can, you can use the approach she has showed us, or you can go on and use the table format. All approaches are okay. But whenever you are using the other approach, make sure you write your work in a vertical format. That for my first optimal point is this, second optimal point is this, third optimal point is that. Do not squeeze your things after you write one here, you write the second one here, you write the third one. Have your work very organized and well planned in a vertical format. Then another thing, I think someone was asking in the chat, I think I can look in the chat, where they use the selling price. That one is an objective what? An objective function. So you can tell us the objective function, and then you proceed. That is the objective function, or maybe total profit, maybe total this, and the rest of that. Then those who are using the table, make sure that at least 3 columns are well seen, that you have okay. Okay, let me just go back to, okay. Make sure that your 3 columns are well seen. You have a column for the optimal points. You have a column for your substitution where you're doing your substitution. Here we expect you to have that objective function, and then you have another column for the outputs. So we expect you to have that, and do not forget always to give us the response at the end of your thing. But defining the inequalities you are using, do not forget that it is very important that let x be the number of this and this. Let y be this and this. Yes, don't just avoid mentioning this. X is uniform. Y is maybe this and this. Maybe this is tables. These are write it well that let x represent the number of sets of uniforms. Let x represent the number of tables. So we expect you to be able to define. So I think now I'm looking. Is it okay? Yes, as long as your naming is on the graph. Name on the graph. Name on the graph. Okay, I'm looking through the chart. I've showed you the correct way. I've showed you a sample of the graph. How do you determine the best scale to use? Here you can apply your knowledge of physics. You can apply your knowledge of physics on how you draw those physics graphs. But always, before you determine the scale to use, look at the tables at the values you are going to plot. Identify what is the largest x value I have and what is the largest y value I have. That one should give you a hint on what scale you are going to use. But always multiples of 5 and 10 are good scales. Multiples of 5, multiples of 10 are very good. But at worst, in case things are not working, you can use the sub-multiples of 2.5. Okay. Which side should I? Now, always when it comes to the testing, when it comes to testing which side to shade and the rest of that, always we shade the unwanted, and I don't know where my graph has gone. Always we shade the unwanted what? Unwanted region. So you check out which region is not satisfying the inequality. A case in point, when you look at this graph here, like our presenter was telling us, when you look at this graph here, you can notice that in case this is the line, you notice this is the line we had. This is the line. When you look at that line, it had an inequality of 2x plus 3y less than or equal to 150. Now you can ask this line. You have this side which is A, you have this side of B. So you choose any coordinate either from A or from B, depending on what you want. But in case I'm at this side of A, I can decide to choose this coordinate. And this coordinate here is 10 and 10. So when I take on 10 and 10, I go to my equation that this is x and this is y. I substitute. So 2 times 10 plus 3 times 10 less than or equal to 150. So this is 20 plus 30 less than or equal to 150, which gives me 50 less than 150. So I ask, is 50 less than 150? Does it make sense? Is 50 less than 150? That yes, it makes sense. Eh? The moment you find that this inequality is making sense, that 50 is less than or equal to 150, then you say, yes, it makes sense. So that is the wanted region. Whenever the inequality is making sense, that is the wanted region where you have picked. So that means that the other opposite side is where you are going to be shading. In case that inequality doesn't, let me say we had picked a point where we have B. Take an example, I've taken this point here, which is this point. Okay, let me take this 50 and 50 somewhere here. If I take on 50 and 50 to be 2 times 50 plus 3 times 50, let's equal to 150. 2 times 50, this is 100 plus this is 150, let's equal to 50. So which gives you 250. So you notice that 250 is not less than 150. It does not make sense. No sense. So in case doesn't make sense, that is the region you go on and shade. But for cases where that line is on the side of 0, 0, always 0, 0 is the best point to choose because it doesn't involve quite a lot of calculations. Okay. 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 How do you choose the test points? The test points are the best ones to first look at. You look at the sharp points. Many times when you draw these linear programming things, you'll find that there is a shape they usually form. So the first points to test out these points that are forming the shape or along the line. Those are the first points you have to test. But however, please take note, we always do not consider points. In case the point you are taking is giving a point, those ones we do not, because you can't have a half a table, a half a chair, half a cow. So we don't take on points or decimal points like 6.6, 7.7. No, we always take on integers, and integers are positive, whole, and negative whole numbers. But also remember, we can't have a negative chair. So we always take on positive integers. So we expect to have positive whole numbers. So the first points to test on are the points at the sharp points. Now, after testing on that one, please do not take it that if you have dotted lines, let me say this line was dotted, we don't take on dotted lines. Where you have dotted lines, we don't take them on. And we don't pick points where we have dots or where a whole line meets a dotted line, because this point here, it shows us that one of those points is not part of the solution. Whenever you find something dotted, it indicates that it's not part of the solution. So we do not take it on. But first check out on the sharp points, and then those points that are near the line. These points that are along the lines you have drawn, in most cases, are the points that will give you the optimal points. 2x greater or equations to y. Now for equations, now like that equation they are asking, let me say y 2x greater or equal to y. I think that's what. Now when you have such equations, this equation, let me put it in this format, 2x. When you interchange, the y comes this side, this one comes this side, and you have this. Now, dear students, you notice that whenever you do not have the intercept, here, the x, y, in the intercept approach will not work for you, because you notice that when your equation will be y is equal to 2x. So when you say x is 0, automatically y will also be 0. What does it mean? It means that here, for such cases, increase on the number of add more values of x, when x is 1, when x is 2, when x is 3. And then substitute in the equation that 2 times 1 will give us a 2. 2 times 2 gives us a 4. 2 times 3 gives us what? A 6. Then after, extract your points. Always extract your points from the table, that this is the table I do have. Then after doing so, come on your graph. Let me see where my graph is. So allow me to first, I don't know whether I can have my graph back. Let me first put my graph. So you are noticing that I'm going to be drawing a graph of this nature, where I have 0, 0, I have 1, 2, I have 2, 4, I have 3, 6. So when I come here on my graph, when I'm plotting, I'm going to come here. Let me say this is my line. This is my line here. So I'm going to have something like this, I'm doing something roughly. Let me say this is 0, 1, this is 2, this is 3, this is 1, this is 2, this is 3, this is 4. So when I plot, 0, 0 is here, 1, 2 is here, 2, 4 is here. So allow me to just plot it quickly. So it will be a line of that nature. It will be something like that. Now, after that, I will label it very well that this line here is the line y is equal to 2x. But what do we want? We wanted to shade y is less or equal to 2x. What do you do? Label that this is this. In case I want this region, I will label region A. Then I choose any point from that region. Take an example. I decide to take on this point here. When you check on this point on my graph is 1, 3. So I'm going to go and test. I have my point 1, 3 that I'm taking and I'm feeding it in this inequality. So this is your x and this is y. So my y is 3 less or equal to my 2 times 1, which gives me 3 less or equal to 2. I ask myself, does it make sense? Is 3 less than or equal to 2? That no, it does not make sense. So that is the region that doesn't make sense. It's the one I shade, and I will shade like that, like that, like that, like that, like that, like that. So that's how you deal with such inequalities. And please take note, never choose a point on a line you have drawn. The moment you choose any point along the line you have drawn, you'll find that your inequality is equal. You'll find something like 2 less or equal to 2, 3 less or equal to 3. So such thing, it is an indicator that you have chosen a point along your line. Okay. No, here, please avoid having negatives. Avoid dealing with negatives because we can't have negative thing. But also, please take note, you must be very careful when it comes to linear programming because those who do programming, you know very well that once one inequality is wrong, there is no way you'll get an answer. In case one code in your program is wrong, a program cannot run. So you need to be very careful when you are dealing with the inequalities. How do you shade x is equal to y? No, that one is not an inequality. Y is equal to x, but that is a line that goes like here. 1, 1, 2, 2, 3, 3, like that. So it will be a line like this. Yes. So there must be an inequality. Is it less than x? Is it greater than or equal to something like that? So it can't just be y is equal to x. Okay. How do you notice along the line? No, like I'm saying, some of you sometimes you choose points along the line. Take an example. Someone may be testing and he chooses this point 1, 2. Now, the moment you fill in 1, 2 in this equation, you are going to find that y is 2 here and x is 1. So you get something like that. So in case you ever choose any point along the line, it means that you'll not be able to determine which side to shade because you can't shade it, in other words. Okay, I think those questions are enough that I've been able to see. Then I think let me pick one question from Queen of Peace. Yes, Queen of Peace, unmute, and maybe I think even Bishop Dustin has a question.
Is the objective function considered as the inequality?
Now, is it considered as
an inequality or an equation?
Now, whenever you have an equal sign in something, for something to be called an equation, we look at the equal sign. So since it has equal sign, it is considered as an equation.
Okay, thank you. Another question was about that if we reduce, for example, I had 30x plus 20y is equal to 100, and I reduce them. The final answer which I get, it's the one which I wrote on my graph, like 3x plus 2y is equal to 10, or I write the other one original.
Write the equation that you reduced.
Okay.
Yeah, but when you are starting this question or when you are starting these items, avoid, let me say, now for that case, when they tell you that write the inequalities, do not write the reduce first, like this inequality they had, it was something like this. Please let this inequality be seen, be visible before you make your reduction. That I remain with 2x plus 3y, let's say equal to 100 what? 50. Let this inequality be visible somewhere. That is the inequality you reduce. So let it be, because that is the inequality that you were able to obtain from what? From your from what? From your
From my
scenario. So let it be visible before you go on and reduce.
Okay.
And never forget the objective function, because it is but though for it we score it the other side under formulation when we are looking at the table. Okay, Bishop Dustin, it seems you have a question. Bishop Dunstan?
Hello?
Yes,
Is anybody
please.
hearing us?
Yes, we can hear you.
So I was requesting to share the screen a little bit to ask the question.
Oh, okay. You share your screen. Let me stop sharing.
So, so is anybody seeing the screen?
Yes, we can see it.
So the question is, sometimes we find graphs like this, whereby this side is the feasible region, and we get difficulty in picking picking majorly the maximum coordinates to use to find the maximum costs or profits that are needed. So how can we handle that?
Now, okay. Now, one, yeah, I know it is possible, but if you meet such a case, like you have shaded something like this, oh, okay, I think it was something like this. Now, for such a case, what you do, you can, this point here, if those lines are bold and they're part of the solution, this point here will give you the maximum point, given that that scenario you did had only two equations. So this point here will be the one to give you the maximum point. All points along this line here, those are the ones that you'll choose. But in case, let me say they were dotted and you had shaded. Now, for such a case, what you do, you look out for the points that are very close to the intersection of the two inequalities that you shaded. So you look out for the points. Those are the ones that will give you the minimum point. Yes,
And
but also,
another thing,
yes?
we were asking to repeat for us how we can formulate the title of the graph.
The title of the graph. Now, the title of the graph, I don't know whether, let me see whether I can retrieve that graph. Now, when you look at the graph, let the title speak to us. What is the graph showing? Yes, because let the graph talk. What is it showing? That a graph showing the feasible region between the number of tables and the number of charts. So let it speak what it is showing. So the keyword that I want to appear there, let that word showing a feasible region be visible. That a graph showing the feasible region of the Taylor's condition. A graph showing the feasible region between this and this. In case you can even make it better, a graph showing the feasible region between the number of chairs and the number of tables. Let it speak, because the title of the graph must be able to show us what you have plotted and what you are describing, or what the graph is talking about. That is talking about tables and chairs. So let it show us that what you are showing us is a feasible region, and it is about tables and chairs. Okay, hope that is clear. Okay, I'm still looking through the chat. Okay, last one, Nicholas Muyomba.
Yes, hello.
Yes, please.
I was asking on if the question does not have any part that's showing you that it is at least or at most. How do you know
Now,
the inequality to use?
I've said one of the words that you are going to meet, I've said one of the word is has. When I use the word has, that maybe Nicholas has 50,000, has also shows an inequality. But for such a case, when they use has, it means that that is the maximum amount of money that you have. So maximum means less than or equal to. But when you look at my screen, these are other words that can be used. When they don't use the word less than, when they don't use the word greater than. So when they don't use those words that are a bit common to you, like at least, the word at most, these other words can be used. They can say the minimum amount is this. So you need to know that minimum means greater than or equal to. Maximum means less than or equal to. Minimum, it means that you can have more than that. Then other words they use is not below, not less than, fewer than. Also those are other words they can use. So this table I'm showing you at least should give you a picture of other words that can be used in the scenario. In case they don't use those common words, you know.
And also on the graph, they encourage us not to use rep on the scale. They told us to use the two dots instead of the rep. Rep will mean another thing, and you will lose marks.
Yeah. When you look at this graph, hopefully you cannot see this graph I'm showing you. It is clear. It says 1 centimeter represents this. So do not use those abbreviations.
The last question is on the optimal points and the substitution plus the
output.
That table. Then the output. I didn't understand on it very well.
Oh, I said that sometimes some of you, or sometimes we may encourage that we can choose the optimal point. So I'll draw a table. I write here. Let me use another color that is a bit visible. Let me say I'll write here that these are optimal points. Then I say here, this is substitution and this is my output. Then under substitution here, I'll include my objective function. Like here they had selling price. I think that's what they used. They said selling price or selling something. Yes. So here I'll write my function that I'm going to feed in, that 90,000 x plus 60,000 y. Under substitution, then I start choosing the points 15 and 40. So here I will show that this is 90,000 times 15 plus 60,000 times 40. And what is the output? 375,000. Then I go to the second point that this is 17 and 39. So I substitute in, I show my substitution, 39, I put the amount. I go to the next 5 and 45. I substitute in, I put the amount like that. So that is the table. Then from there, I will only look at the output and then I select, in case it is maximum, which one is giving me the maximum amount, and in case it is minimum, which one is giving me the minimum amount. That's what I'm saying. Then I know there are cases whereby, let me say, someone has taken on 0 and 40, something like that. I'm just giving an example. Here, before you, in case 0 and 40 is giving you maximum or minimum point, I want you to first go back and reason. Because you may find out that in your inequality, they told you that x should be beyond 20 and y must be above what? 30. So for such cases, such an output of 0 and 40 will not work because already they had specified in the question that X and Y must be above this or must be above that. So we do not expect anything like 0. So you need to keep on reasoning before you make your final decision. Okay, I saw a hand up. I want to sum up this now. Okay. Okay, let me hope. What if we choose points on a line? What if we choose points on the line? Now, the points along the line, if that line is bold, it is okay. Given that even those points we are choosing are not points, that's okay. Yeah, that is okay. But in case they are dotted, please, we do not choose them. Why did the platform? No, the equation the presenter used, it was the objective function. It is the objective function. How many optimal points? I repeat, I've said the number of optimal points, at least 3. At least 3. But please choose as many depending on the time you have. But at least 3. Make sure you have at least 3. Don't make a conclusion just basing on 2. Have at least 3, 4, and the rest. Where do you get? Now, in case the graph you have plotted has dotted points, then get the points in the region that has remained. A case in point for such, in case it was dotted, then we expect you to look out for points in this region that has remained here. That is when it is dotted. Okay. Okay, I think okay, I think that. Okay, but as far as I know, the equation that I have showed you of 60,000 and 90,000 something, that was the equation for the output. Okay, the last one, okay, I think that is enough. Okay, I want to give 5 minutes to which school, to just do something small. I don't know whether it was Kango. Yeah. I'm not saying that school on. I don't know whether they are still on. Kango. Are you still on the girls' school? Kindly let me know through the chat whether you are still on. Okay. In case they are not on, Global Eden, can you just do for us just one part? Not everything. Not everything. I don't know that you are set. Global Eden, kindly unmute and let us know. Global, are you set? Just one small thing. Yes, Odrav, a question? For the numbers you have asked for, I'm going to throw some light at the end.
Hello.
Yes, that is Odrav.
Yes.
Okay,
My
Odrav.
student. Yes, my students wanted to present question number 1.
1. Okay, can we firstly check whether Global is set? Global, unmute. Global, unmute. Oh, I think we are failing to get Global. I'm saying you, but we are failing to get you. We are failing to get you. Okay. I don't know. I want to first confirm. So Global Eden, we are failing to get you. So we shall pass on the opportunity to Odrav. Okay, Odrav, you are going to do for us something small because I'm saying it is getting time for supper. So do for us just one part of item 1 or draft. Kindly unmute.
Okay, the presenter can come. Somebody should sit there. Let somebody be there. Somebody be there. Exactly the video. So I'm coming to present item number 1. That's enough. Part A. Task A. So it is about ratio, number, percentage, and others will be applied during the calculations. So when you read this item, you realize that we have some parts here whereby when you relate it to the task, you have task A, which reads type iron as salary according to our land ratio. So when you read the scenario, you realize that on the upper part, task A is related to it. So here I'm going to do it. That's part A. So here it is F iron cubic as salary according to our land ratio. So the land ratio is the land ratio is 4 is to 2 is to 1. So when we do amount according to this ratio now. So when we distribute this amount, UTS million and 800,000. So since it is going to be distributed according to school requirements and output respectively. So for that, we're going to get the total ratio. Total ratio will be equal to, we add these numbers, which are this ratio now. This is 4 plus 2 plus 1. Now we get 7. So this is our total ratio. So we are proceeding. Since we are going to distribute this money according to, and we're going to distribute this ratio. The money is same amount here. The amount, the amount. Same amount, UTS, 2, UTS, 800 and 1,000 is allocated by algorithm and is supposed to be distributed according to school fees. So from here, consider this ratio. The first now you read this. If you read the statement, you realize that school fees comes first. Therefore, this 4 represents the school fees. That this 2 is for School requirements and this one is for the output. So we're going to get the amount of they're going to take for school fees. Now to know this 4 over the total ratio, 10 times the total amount which is allocated, which is 2 million. 1,000.
1.6.
So we're going to cross by 7 is 1, by 7 is 400,000. So this will now be 4 times 400,000. So this will give you UTX 1,600,000. So we're going to conclude. So in conclusion, we're going to say that therefore, since your commandant Ivan, it will not fit. Therefore, Ivan solely allocate UTX, that's 1,600,000. That's now for fees. So we proceed. For school requirements, so we have the according to school requirements. No, we also consider this ratio, mean that this 2 is for school requirements. So we shall have 2 over the total ratio, which is 7 times the total amount, which is 2,800,000. You cross here by 7 is 1, by 7 is 400,000. So we can multiply this one here. Now this will give you UTX 800,000. So don't forget about the conclusion. You're going to make a conclusion. Now in regard to this one, you're going to say so therefore I will allocate UTX 800,000 for school requirement. School requirement. So we're still continuing. So it was this amount 4. So we're still remaining with outputs. That was get to use the lecture. So for output, now this is what that's the 1 over the total ratio. That is 7 times the how long? 2,800,000. So here you cross here, then you cross here. You cross here. 1,000. So when so from here you realize that it's now obvious to write this 1 times 100,000. So if I just write your answer, and it's 100,000. So don't forget about the conclusion. From here we're going to make our conclusion. So in regard to this, the conclusion must be in form of tendency. So from here, in regard to this one, we're going to make conclusion like this. Therefore, UTS 400,000 be allocated by island for up. So dear moderators, since I was given I'm done with I'm done with it. Okay. There are questions. Yeah. Dear moderator, if you look for one, B. Okay. So my colleague, welcome. Is there a question? Yes, thank you. That's the same. Based on your calculation, when I will try to be allowed to go to school, just fine. Okay, this is how we came up with it. Now, the amount of comments of we have given the next opportunity and they are coming and find the need increase. This is the next now, from here, we are coming to this. Cannot say, go on to 7 million education. So here, service that important. Now, they say that they say the 5% of this now, we're coming to find the 75% of this the money allocated for children. Say that the amount million is not the amount of school fees of that school. Now, we're coming to find out the 75% of this 2 million. Okay, let's proceed and see that this year teacher will be admitted.
percent of 2 million. 75% means 75 auto 100. Now it means 75 auto 100 of 2 million. This of multiplication. Here we're going to multiply. Here's now 75 over 100 times 2 million. This zero stands with. When you complete all this, yeah, we shall therefore get 1 million 500. Here. Now, since the amount allocated for school fees by this date was 1,700,000, and the amount, 75% of this, of the total amount of school fees of this school is 2 million. Sorry, is 1,500,000. This from here you can now see that every child will be allowed to go to school because the amount allocated by us is able to cater for the 75% of the school fees expressed by the school. Therefore, you can now conclude by saying therefore, I means child will be allowed will be allowed to report school because the money allocated for school fees and data for the money required. I think regarding this task here, I'm done. If there's need for me to proceed to the next item, the moderator, I'd like to know from you.
Okay, thank you so much, Odrav, SS, for that good presentation. Dear participants, kindly bear with us with the camera. I know very soon we shall get good cameras such that everything is very visible. But the most important thing is for you to be able to follow up what the presenters are saying and are doing. Thank you so much, Odrav. I'm going to give 5 minutes to guess, to unmute, and then to summarize for us that question item 5. Guess, Bishop Dustin, I think. No, not Bishop Dustin. Grob Hayden.
I've been asked to summarize them.
Grob Hayden. Grob Hayden. Grob Hayden, which mic, which video? Okay.
Okay.
Global,
That will be the
it is
result.
upside down. It is upside down. Okay.
Okay, we are going to
I'm going to request that you switch off the other microphone for the other device that you are not using.
Still.
Reads a group of South Ugandans in the diaspora currently works in Saudi Arabia who have been saving money monthly with a trusted businessman in Uganda. Each of them contributed UDX 850,000 a month. We are going to summarize the question. In summary, there are 12 Ugandans. They have been saving money with a trusted businessman in Uganda. Each of them gets 800 per month. So monthly, this part Uganda save 850. This is the then if you continue with the question, it is per month from January to May. From January to May, which means these are 5 months. The businessman has informed them that their total savings can now buy a piece of land in a good location near Kampala. Here is the plan. 70% of the total savings will be used to buy land. We say 70% of total savings to buy land. Then another condition is from the remaining balance, 2 out of 3 will be used to pay the land surveyors. 2 out of 3 of remainder to pay surveyors. Then the group also requested that the land be cleared before development. The businessman explained that 6 workers can clear the land in 8 days, and each worker is paid UGX 10,000. I think somebody is taking time per day. But the group prefers it cleared within 4 days. Whatever remains after these expenses will be kept as starting capital for the next phase of the development. Roman number 1, that is A, it says, have the diaspora members calculate the cost of land based on their total savings. So, the diaspora members are 12 in number, and each contribute 850 in a month. So, in a month, come on, calculator. These last numbers for a month, they will save 12 times 850,000.
which is 10,200,000. And they have saved this for 5 months. So you multiply it by 5. If you multiply that by 5, you get the amount of UGX 51 million. After that, our question will demand that to calculate the cost of land based on the total savings. So the other condition was 70% of the total savings to buy land. So the amount of money to buy land is equals to 70%, which is the same as 70 out of 100 times the total savings they did in 5 months, which is 51 million. If you press that on the card, it will give you that the 5,700,000. You don't forget the UGX. But this is the amount of money used for buying land. But the total cost for the land includes the amount of money given to the surveyors. So the surveyors, the other condition is saying 2 out of 3 of the remainder to pay surveyors. So we first get the remainder where we have 51 million. This is UGX minus the money we got here, which is so here we are getting the remaining money after purchasing land. Which is 51 million minus 35,700,000. So your answer will be UGX 15,300,000. So this is the amount of money remaining after buying purchasing land, but you want the amount of money for surveillance. So amount of money given to surveillance, which will now be 2 out of 3 of the remainder, which is this money. 2 out of 3 of 15,300,000. What does it give you? UGX 10,200,000. This is now the amount of money given for surveillance. So you were asked to get the total cost of money used for land. So cost for land will now be equal to the amount of money to buy land plus the amount of money given to the surveillance. So it is 35 million
700,000 plus 10 million. It is UTS minus giving 45,900,000. You don't leave it flat, you conclude. Therefore, the question is saying the cost of land based on the total savings. The cost of land is Uganda shillings 45,900,000. That's the final answer. Thanks. My colleagues are happy.
Okay, thank you so much. Starting part B of the question, what is the take-home pay for the land surveyor after the land has been purchased? To get the land, to get the take-home for the surveyors, we are finding the take-home for the surveyor. To get that, we shall get two out of 3 of the remaining balance. How do you obtain this remaining balance? This remaining balance is obtained from getting the 70% of this initial money, this total savings of these 5 people. After getting 70% of this, you come and get 2 out of 3 of that remainder, then it will remain as then take home from the surveyor. Now, we get the 70%, we are getting the remaining balance, 70% of our total savings, which is 51 million. When you cross carefully, it will, what does it mean? 70% of 51 million. Yes? 35 million 700,000. This is in Ugandan shillings, but this is not what you want. This is the money which was used in the other side, but we are invested. This is still the 70% of this 51,000. So we want to get the remaining money. So we shall send the remaining money, which will be equal to 51 million minus this minus 35 million 700,000.
This is 15 million, 300,000. This is in Uganda. This is UGX. This is our remaining money, but it's not still the take home for the surveyor. So to get take home for the surveyor, we shall say 2 out of 3 of these 15,300,000. We shall get it after finding 2 out of 3 of this money. It will remain as the take home for the surveyor. So we shall say take home is equals to 2 out of 3 of this 15,300,000. So of simple means multiplication. 2 out of 3 of this 15,300,000. This is UGX. 10 million. 200,000. So this now the final answer take home for the surveyors. But the question is saying, what is the take home for the land surveyor after the land has been purchased? So you give a viable conclusion by saying that, therefore, the take home for the land surveyor after purchasing the land is UGX 10,200,000. Now this is now the take home, the money that the land surveyor will go home with. Thanks.
Thank you so much. I'm going for question C. It says, how many more workers does the businessman need to hire to meet the demand of the diaspora people? What are this question one? This question needs us to find the number of workers who will be added to those 6 workers in order to reduce the number of working days. So our heading will be more workers needed. Workers needed. We don't know the number of workers who are needed to work within these 4 days. So we are going to let the number of these workers, let the number of the workers of more workers needed be X. So the question is, the group also requested that the land be flagged before development. The businessman explains that 6 workers can clear the land in 8 days. 6 workers can clear the land in 8 days. But the group deposit clear within 4 days. So we don't know the number of workers who will work within the content.
Okay, I think we are losing out. I'm going to ask the teacher for the remaining part to record for us that part, and then we shall proceed because we are failing now to get you on the sound. And you're going to allow me, to just throw some for just 2 minutes because I know it's getting late. People were asking something on number, I think, was it number? I think it was number 7. Number 7 required you to know to use the knowledge of equations of lines combined with functions to be able to come up with a solution. But the rest of the numbers, but it was done yesterday. We are finalizing with the recording, so you'll be able to check out for that recording. Then the rest of the parts, you can go on and go through for the rest of the numbers, but we shall share the final solutions. But would like to encourage all the schools to work out the numbers and then we shall start from there. Okay, but we'd like to thank you so much for your commitment and for being around. We are going to have more seminars coming on after this week. Starting next week, we shall have our daily facilitation sessions from Monday to Saturday for those coming weeks. The next seminar we shall have will be chemistry, but from around, I think it will be 7th. Starting that week of 7th, we shall have daily facilitations, but they will start at 4 p.m. in the evening, and they will run for 2 weeks from 7th to around 18th of July. We shall have seminars, facilitations for all the subjects for those 2 weeks. Would like to thank you so much, and thank you all the teachers and the school administrators that have been able to connect their learners, but also for the children that have been able to be here up to this time, to sacrifice your time. We do pray that all your efforts, all the sacrifices that you are making may yield whatever you wish for yourself and for the administrators and the teachers. May all your sacrifices yield the best results for your school. I'm going to request one volunteer from any of the schools to lead us in a closing prayer and to wish us a good week. I don't know whether St. Mary's Ediofe, or we have Kanyatorogo SS. Kanyatorogo SS, I don't know whether you can have one volunteer to lead us in a word of prayer as we close off this session.
Are we audible enough?
Yes, Mary Ediofe, you're okay.
Okay, let us pray. In the name. Heavenly Father, we bless your name. We lift your name up high. We thank you so much for this great day, for the blessings you brought upon us. Thank you so much for leading us through this session wonderfully. And we thank you so much for everything you've done for us, for the knowledge you've given us. Thank you for the schools that were able to present to us, oh Lord. And may you bless each and every one of them. And may you bless us with the knowledge and understanding as we go back to class, Lord, the Spirit and fly us. Lord, lift your name high and bless him in Jesus' name. Amen. Hail Mary, blessed is the Lord, pray for us now in the name of the Father and the Holy Spirit.
Okay, thank you so much and have a good evening, everyone. Thank you so much, dear teachers, for connecting your children. Thank you so much, everyone. May the good Lord bless you all and see you. Those who can, I think I need to take this a picture before we leave. Those who can, you can turn on your cameras and at least I take this picture to show people how committed some of you are. And I'm also going to request schools that still have children, to kindly take that night photo. At least it will be very good to share and to show people, and we shall keep it until when the exams are back to show people that all the efforts we put in were not to waste. We are going to share with you a lot of materials, so teachers, keep in touch with us. We are going to share with you, and we want to ensure that everyone, St. Elizabeth, kindly take that photo and share with us. St. Mary Zediofe, Ronnie Rico, yeah, we love you so much, and may good Lord bless you. Bye bye, and I wish you a good evening.